Rob or Robert? Robert. I like Robert. My first boyfriend was Robert. I remember that name well.
Hi, I'm Beatrice.
Whoever is the coolest company you got. Yeah, once you start chatting. Quieter.
It's quieter,
Also as well. Right next to like the big Invest in Canada.
I would also mention like which hall you're in, which booth, so that way they can keep talking
I brought my roadie.
with when they see people talking,
Like, what are these guys talking about?
to.
I have no presentation.
Okay, perfect.
No,
Okay.
we're
Okay, perfect.
just having a conversation. No, we didn't practice our questions, so I'm going to just go with it. It's a chance for you to talk about whoever is. Yeah, you guys are. Are you still in? Oh yeah, it was. I know Janine and I know Robert a little bit. Your CEO, but it's been a while. Or John, pardon me. Good morning. Good morning from Calgary, Alberta, Canada. I
Good morning.
yes, the friendly Canadians trying to draw a crowd here from our friends in Germany. My name is Megan Zimmerman. I work in the city of Calgary for Calgary Economic Development. We're the city's economic development agency. And I'm joined with my friend Robert from a very, very cool Calgary company doing work in geothermal. Robert, why don't you tell us a little bit about Ever Technologies and why you guys came to Germany to show off what you're doing?
That's a good question. So we certainly are a Calgary-based company. We set up the company in 2017 with an idea to make geothermal energy scalable on a way that it has never been before. And we do that by building giant underground radiators. So 2 vertical wells connected with a series of horizontal wells connected in pairs to create this giant underground radiator. The beautiful thing about the technology, though, is it means traditionally geothermal has always been about finding a hot aquifer underground. We don't need to do that. We just need to find the heat. And if you go deep enough, the heat is always there. Center of the Earth, 6,000 degrees centigrade. So if you can figure out a way of extracting that heat, which we have done, then you can pretty well do geothermal anywhere on the planet.
Now, one of the criticisms of geothermal, of course, is the ability to provide baseload power. And I know that you guys are trying to address that a little bit. Could you just go a little bit deeper, Robert, and talk about the technology in terms of, where you play in terms of baseload?
Yes, so obviously you have wind, you have solar, which are intermittent renewables. The big difference about geothermal, if you can make it work and produce power, is that it can run baseload. In our case, it can also be dispatchable as well, so it can actually blend really well with solar, but as a standalone energy source, yes, it can be baseload as well. And if you think about beyond 2030, 2035, at the moment, wind and solar is actually the cheapest form of energy, and I think geothermal will join them by about 2035. So if you're a country that has wind and sun, and you have a place somewhere on the Earth, which means you have access to geothermal, then you have a path to energy independence by 2040, by 2050. And that certainly is what's driving the conversation these days with a lot of places around the world.
I have to pick up where you left off around all the energy sources. So many people know Alberta as a place for oil and gas. We certainly have a lot of that, 3rd largest oil reserves in the world. We're also a province that has a lot of wind and solar and other sources of energy. Could you speak a little bit about why you decided to start Ever Technologies in Calgary, and what's the advantage or rationale for being in the province of Alberta and within Canada, and of course headquartered in Calgary, Alberta?
Geothermal is built on a foundation of technology development and success in the oil and gas industry, particularly in related to Canada, to the heavy oil industry, in North America generally from the shale industry. So the ability to drill long reach horizontal wells in a matter of days, when previously it used to take months. So that development over the last really 20 years has provided a foundation, a platform upon which we can build. So it's a natural place for us to have built the company. The center of expertise for oil and gas and drilling technologies is in North America, and certainly in Canada, the headquarters of that knowledge base is Calgary. Yeah.
Always comes back to the people.
Always comes back to the people.
Yes.
And actually, one of the challenges that we face beyond 2030 comes back to the people. What we want to see is more investment in people development, and sadly, because of a potential decline in the oil and gas industry, kids coming out of school no longer see a geoscience degree or a drilling engineering degree as something that has a sustainable future. And so we are sadly seeing a decline in the number of those degrees. And that's a big concern for me, for our company, for the world as well. So we need to find a way of reversing that. So we are working with universities in Calgary, in Canada, looking at ways of reinvigorating those programs so that we always will have the people that we need to continue to grow.
You got to make energy sexy again.
Yes, we need to make energy sexy again, yes.
Can you talk a little bit about the company's been around since 2017? Obviously, a lot of focus on R&D and really proving your technology, Robert. Could you speak a little bit about where you are today? You
Okay.
have some commercial operations. What do those look like? How can people learn a little bit more about the business where you're at now?
Yes, so it's an interesting story because when we started out as a technology company, and we are a technology company. The name is Ever Technologies. It's not Ever Development Company, it's Ever Technologies. So we had a concept and an idea, and we said, well, this is fantastic. Everybody will want to license our technology. Of course, that turned out to be very naive. So they said, no, you have to prove it first. So what we did in 2019, in the space of a year, we built a working prototype in Rocky Mountain House, just north of Calgary. And that project was 2,500 meters deep, 2 drilling rigs, 2,500 meters apart that drilled and then met in the middle. And we did that twice. Filled it full of drinking water, had a small pump to initiate it, but then it just runs naturally by itself. So we said, okay, it works. We had hundreds of visitors from all over the world who came to look at it. And we said, okay, now do you want to license the technology? And they said, no. You need to build a commercial system. So we set about then looking for the first commercial project, and that's how we arrived in Germany. And there are all sorts of reasons why we're in Germany. It has a very attractive district heating market, has incentives for geothermal power. So the first commercial project, which has been under construction for just over a year now, is in Bavaria, just south of Munich. When it's finished, it will supply heating, district heating for 2 towns nearby, Geretsried and Wolfratshausen. It will also produce power in the summer months when there's less demand for the heat. We have a visitor center, and once again, we are attracting people literally from all over the world to visit it. This time, this looks as though it's going to be big enough because we've been able to farm out equity to other developers. And what we're doing is, not only is the technology scalable in the sense that you can make this work anywhere, the business model is scalable as well. So we've attracted investment from a number of different energy developers, oil companies, but also utility companies who've come in and said, yes, we believe in this technology. We believe that we can get the price down to a point where it makes sense everywhere. And so finally, after 7 or 8 years, we're starting to see that vision come through of having a technology company which is scalable and people can license the technology.
I see the crowd forming, so I'm going to ask a question that hopefully is beneficial for you. You're here at Hannover Messe. You have your commercial pilot plant here in Germany. Who are the perfect partners? Like, who are you looking to meet while you're here in the market? Just a call out to our friends that are listening.
Well, we have a great relationship with our friends from Hatch, who've been very supportive of our first commercial project, and we're in discussions with them about the support that they can provide in the development and design of these massive projects as well. The companies that we're and organizations that we're hoping to meet here, and actually we met a few of them yesterday, come from, it could be a country that's here looking and thinking about energy independence. And what does that mean for that country? Is it 10 gigawatts of power by 2040? Is it 20? Is it 30 gigawatts? How big is it? It's corporations that are looking to decarbonize. So we had visitors from Qatar yesterday who are looking for around 400 megawatts to decarbonize their steel generation operations. So it's conversations around decarbonization, energy independence, energy security. Those are the organizations, the countries, the governments that we're hoping to meet this week.
And in a lot of ways, Europe is a leader in that, right? So they're seeing probably a lot of opportunity to bring you into their markets. And I think what you're doing is quite unique, right? When you talk about the geothermal space, what you've done in terms of that radiator technology is quite unique, where you're not dependent on the natural heat of a specific jurisdiction that you're working in. Could you speak a little bit about what makes you really unique, in terms of, or how you're competing in the market? Is there anybody else trying to do similar technology to you, or are you really quite in a class of your own, Robert?
Well, the way we approach the market is to say the answer to the question is yes. Okay, what's the question? The question is geothermal energy development possible today in my location for my application? And the answer is yes. It wasn't yes 10 years ago, maybe not even 5 years ago, but it is today, because there have been a series of interesting technological developments, not just ours. We are one of those components. The good thing for us, of course, is that our technology will work everywhere, and so in 70-80% of the cases, the answer to the question of which technology is it, it's Canadian technology from ever. But we start with that question, and this is what we encourage everybody to do. Look at the geology. What is under the ground? How hot is it? Do you have a beautiful hot aquifer under the city like you have in Munich or Paris? In which case, exploit it in a conventional manner. But in most cases, you won't find that aquifer. So what are you going to do? The heat is still available. How do you extract it? So the first question is always about the geology. The second question then is about, well, how much heat do you need? When do you need it? Is it seasonal demand? How much power do you need? Because that, again, will help you determine what type of technology or approach that you need to take to develop those resources. So that's what we encourage everybody to do. It's not just a question of, okay, here's our technology, will it work? It's a question of figuring out how or if we can support a city, a corporation, a country reach their energy security goals. Yeah.
Are you having conversations with any Canadian jurisdictions about putting the technology in Canada?
Yes, Canada, when we first drilled the pilot project in Rocky Mountain House, there was no legislation for geothermal energy development in Canada. So we had to permit it as two oil and gas research wells that just happened to meet in the middle. Since then, of course, we have worked with the government to put geothermal legislation in place, and that has begun to really open up the market for geothermal energy. So we think there's definitely potential for large-scale power production, particularly to support hyperscalers, the big IT companies that are starting to arrive in Canada. And I think initially they will power their data centers most likely with gas, but with the view to making the transition to renewable energy. And then on the Atlantic side, the Atlantic provinces, we're talking about how do we blend a geothermal power generation with offshore wind, which is intermittent. And there's obviously discussions about wind production, and that wind production, which is more than the local communities need to produce hydrogen for export to Germany. So when the wind isn't blowing, can we use those electrolyzers with geothermal power to make that capital efficiency better for those electrolyzers? So yes, and then up in the Yukon, we've had ongoing discussions for a number of years now. We've started to think through very high-level plans for a 400 megawatt electric project, which is more than the Yukon actually needs, but it also, with that excess energy, it then gives them a basis for starting to think about how do they develop their economy beyond the current energy requirements. The final one is I mentioned, is a project in Saskatchewan with a mining company that is looking for renewable baseload heat to help decarbonize their mining operations. So yes, a whole series of potential projects.
A lot of use cases, and as you say,
yes,
a lot of opportunities for the and in terms of different
correct,
types of energies working well together.
Yeah,
right.
And it's all built on the foundation of the oil and gas industry, which is really, really strong in Calgary. And so what we want to do is build on that foundation and turn that into not only an opportunity for Canada, but an opportunity for export and to support the drive for energy independence and energy security around the world.
Let's look ahead to the future. Let's say it's 2030, Robert. What's the milestones on the horizon forever? Where do you see yourself in the next 5 years?
If we take a step back and talk about wind and solar for the moment. So the first offshore wind turbine was priced at about $650 per megawatt hour. Super expensive. And that, of course, over time has dropped down. There's been this so-called learning curve to the point now where it's being built at scale and prices are $50 per megawatt hour or lower. The first solar PV plant came in at around $1,400 per megawatt hour. Super expensive. And everybody said, well, why would you ever consider building another one? Of course, then you get into economies of scale, and now solar PV plants are being installed in Middle East at massive scale. generating electricity at maybe $20, $30 per megawatt hour. So the journey for us is just beginning. Our first project will be at a price of around $550 per megawatt hour, so similar sorts of numbers. The learning curve we know is real because we've seen that from the oil and gas industry. We've seen that from drilling long reach horizontal wells, which used to take 3 months, now take 8 days. Companies like BP and OMV have invested because they also believe in that learning curve from their own data. So between now and 2035, it's a series of projects coming down the learning curve, crossing different economic thresholds. Firstly, district heating, and we've already crossed that one. The next one would be power in Germany, where you have quite a high feed-in tariff. Then power in maybe some remote locations, island locations. And then finally, by about 2030, we cross the magic geothermal power everywhere threshold of around $70 per megawatt hour. So that's what 2030 is all about. It's about stepping down that learning curve to the point where the business model works, it's scalable, the technology is scalable, and the price is at a point where the demand should be global.
That's $70 a megawatt hour by 2030. Is that, you think, is that where the industry is chasing? Or that's Ever's?
I mean, if you look at the recent IEA report that was published in December that was talking about, okay, what price does geothermal power need to be to create global demand in pretty well any market? And 70 seems to be the magic number. But that's not where we're stopping. We're heading below 50. That's the goal. Okay.
For people that want to talk to you, Robert, where's the Ever Technology booth at Hannover Messe?
Just over there. It's on H65 in Hall G13.
Perfect. And anybody that wants to talk more about Calgary, Alberta, Canada, well, there's lots of Canada here, as you've seen. But the Calgary booth is in Hall A17. A little bit of a walk. Robert, thank you. Anything else? Any last message you want to leave people?
Well, no, I'm happy to, if anybody's got a question.
Yeah, anybody have a question for Robert about Ever Technologies, geothermal, Calgary, that we can help?
So are you referring to something called the Alberta Drilling Accelerator? Yes. So that is moving ahead. We are sponsoring it. The Alberta government is sponsoring it as well. But the idea is to make it as a research hub for drilling technologies. Not just for what we want to do, but what could be done on a global basis for all technology, all geothermal drilling technologies. I mean, the holy grail, frankly, is we need to get down to about 15 kilometers. Once you get down there, geothermal power at scale at a really good price becomes possible. We think we've cracked the code on that one, and what we want to do is develop that technology in Alberta, invite other companies in. I mean, of the entire supply chain today, we probably account for about 7%. The other 93% is generic oil and gas technologies. So we providing that enabling technology, and we want to continue to secure that enabling technology in Canada for Canadian companies, so that we then become the enabling technologies for growth of that technology on a global basis. Yeah. Okay, great. Thank you.
Robert, we're out of time. On behalf of Calgary Economic Development, the City of Calgary, and Ever Technologies, thanks for coming to our talk this morning.
because it. Good morning. Welcome, everyone, and I'm very pleased to be here today, especially at this grand show. Question to the audience: do manufacturers treat energy as a controllable input cost? The answer by most would be no, they don't. They think it's something that's fixed and they can't control. I'm going to tell you, and I'm going to go through a presentation today that's going to talk about how customers can save thousands of millions of dollars per year by thinking differently. I'm Dave Arkell. I'm the president and CEO of 360 Energy. We're a Canadian-based company that have been in business since 1995, and we work with customers throughout North America, typically energy-intensive customers. If you talk to us afterwards, we're at E62. I'd love to talk to you if there is an interest. So here we go. I'm going to make a compelling case of what you need to do to make energy controllable. So here's the situation. All around the world, doesn't matter where you are, Germany, Canada, United States, England, most utilities are set up, the energy ecosystem is set up to ensure that you don't actually manage energy that effectively. You actually don't procure that well, and they give you limited choices or options of what to do on consumption. Effectively, they really are teaching the customer not to be proactive in managing the energy. In fact, I know in talking with utilities, they actually will say, it's actually not the customer's job. We will take care of that. That's a mistake. And I can tell you, with the work that we've done over the last 30 years, we've demonstrated to customers, actually when customers take control of their energy, it's one of the best returns on investment they can make annually. So there's really an untapped opportunity for manufacturers to start thinking about how can they control and reduce energy. And so I'm going to say to you, not only has it been an opportunity in the past that's been missed, but it's actually a requirement that's going to be needed in the future. Because actually what's going to happen with this whole electrification side is that customers will need to start looking at other options. The grid won't have the power that's required. You're going to have to start looking at options that maybe you've never thought of before in your life. And in fact, I would say customers will be saving the day for the energy industry going forward. Allow me to explain, this is a picture of the energy ecosystem. Doesn't matter where you are, but quite frankly, this is how it works. It looks quite daunting, maybe quite complex, but I'm going to share with you what it is. So effectively, here's the situation when you're looking at the energy ecosystem. You have weather, which no one can predict. Even weather, people can't predict the weather. You have government parties that come into power, and they start setting policy and setting regulations on what should happen in the energy industry and what shouldn't happen in the energy industry. And that could change every 4 years. Then you have effectively a variety of influencers. You have what we call the energy regulators. You have the ISOs. You have the energy program folks. You have academia that's trying to come up with ways of how to make the market more effectively. And then you have your policy think tanks. That's just the top level that a customer has to think about. Then, when we look at the actual grid side, it's actually broken into 3 areas. You have the commodity side, you have the transmission side, and you have the distribution side. Believe it or not, all 3 of those areas are things that people can focus on, manufacturers can focus on, and looking at ways of reducing their cost in each one of those areas. And last and not least, the most important, the manufacturer. And there's thousands and millions of manufacturers that operate differently. Not every manufacturer operates the same way, different products, different industries, different energy intensity. So effectively, you've got this a large economic or energy ecosystem that's trying to service the customer. And so what's changing now is that was fine, but the world's changing. We now have customers that are demanding from their board or their customers to change the amount or the type of energy that they're using. They have to get to net zero by 2035 or whatever. That customer is driving the utility industry to change radically. The challenge is the utility industry doesn't know how to change radically. They're actually very slow and very methodical. That's not going to work for manufacturers. Manufacturers have to change fast and furious. And so they're frustrated because effectively the energy ecosystem's not catching up to them. So let me just share with you some of the things that are going on in the manufacturing side. First of all, they're now looking at whether it's regulated or deregulated. They're looking at, okay, I'm in Ohio. That's a lot of coal-based. I've got to find a way of reducing my carbon footprint in the electrical side. What do I need to do? So they start looking at virtual power options and looking at renewable energy. And they have to do it very quickly because they have this commitment every year they have to change. Then they're looking at, okay, what are some other options that I can do? Well, first of all, maybe I could generate my own power, or maybe I could do geothermal and heat my facility up with geothermal versus using natural gas. Or maybe what I can do is use battery storage and use that as well. Oh, by the way, I now want to have an electrical fleet, and I want to charge that. Wait a minute, I don't have enough power on the grid to allow me to do this. And this is the thing what's happening, is that what you're assuming that the power is going to be there, you should not assume, because it's not going to be there with the speed of what's going on. And so that means manufacturers have to do something quickly and doing it at the speed that they've never done before. So ultimately what we have, when you look at this picture of this energy ecosystem, you have this grand supply side that is focused on just getting commodity out, getting transmission lines in place, getting distribution in place, and they don't think about the customer. The customer is the last thing they think of, right? They don't move the speed of the customer. Well, that world is changing and changing fast, and manufacturers are demanding it, and they're requiring it. The problem is they don't know how to speak and deal in this environment, because in the utility industry, it's inside baseball. I say that because I worked in the industry for so many years. Utility industry doesn't really understand customers' needs, and they don't, quite frankly, they're monopolies. They don't care. That's just the brutal truth. So ultimately, what has to happen is we have to change that. And the way we have to change that is we have to start educating the customer. We have to get the customer engaged and understand what's involved. And that's what we have been doing the last 30 years to get customers involved. And even without all the changes going on, the money that can be saved and measured by this proactive customer is thousands of millions of dollars. And that's before all the changes that are going to be needed. So the summary is the current energy ecosystem, really, it provides poor visibility to customers to actually understand their energy usage, and they have no concept of energy pricing. It's very limited. And if it is, there's only 1 or 2 people in the organization that know it, not the whole organization. So there's really, quite frankly, a poor engagement with the end-use customer, and that has to change going forward. So ultimately, it's really stopped the customer looking at creative options. What's changing is the customer is going to become a prosumer. They're going to start generating their own power. They're going to start using their power in conjunction with the grid. They're going to have to be so much more knowledgeable about what they do and how they do it. And the challenge is, how do they do it? Because they've never had to do that before. So ultimately, I'm going to share with you what we've done in our organization over the last 30 years. We've developed an operating system for organizations to do. And so ultimately, what you want to create is this understanding within the organization from the CEO to people on the floor about what energy is and what they can do. You want to train them, whether you're a maintenance person, what do you have to do in your role, whether you're in engineering, how do you have to do it, whether you're in procurement, what role will you play? Even our human resources play a role in managing energy because they have to hire the right people, they have to train the people how to think about energy. There's a variety of different things they have to do. And then ultimately, a plan has to be developed that's unique to that customer and how they operate. Not all plans are the same. And last, they have to execute it. And that's the challenge because they've never done this before. So effectively, we are really getting customers to execute things. They've been taught that it's when they're managing energy, it tends to be a project. This is a continuous improvement process. This is not a static one-time thing. And so that's a whole different way of thinking. And then the last thing is you want to track how well you're doing it and if it's working. That's really, really important. I'm going to go through 3 case studies of 3 different industries. In the chemical, in the steel, and also in the cement industry. The summary I want to say to you is each one of these customers had no understanding of energy and the importance of it. They just treated it as an overhead cost. In summary, what we did is we embedded this mindset and thought process so everyone had a role in their organization. And so what's happened here is this client, we started in 2013. Every year they come up with a plan that's customized to them. And they change as the market changes based on their energy usage change. Every year they're finding they're achieving savings, whether it's how they procure energy or how they use energy or the type of energy they use. And it's measurable. And so it keeps on refining, and for them, as they improve their knowledge base, they're faster and faster in decision making, and they actually get these savings even quicker. And so this is just a one-site organization, one site, and there's a number of things that were done here. So from auditing to training to actually putting a real-time EMS system in, and then the people using the information and the making decisions. Oh. The next customer. Customer is 100 sites throughout North America. And really about 34 sites are materialistic to the organization. The challenge with this organization is they keep on buying and selling different sites. So it's really challenging for them to figure out how they need to manage energy. And so what occurred, it's similar to before, is we have to collect data to find out what the current status is. We have to actually train the people on how to use the data, and then each from the corporate site know how to procure, and the individual sites know how to play a role in creating savings. And this organization itself, over 5 years, now we're just showing over a couple years, but over 5 years, with saved over $7.9 million. And the return on investment was 300% over that term. You can't get that type of return in manufacturing almost anywhere. It's one of the fastest returns. Okay, this is a cement industry, very energy intensive industry. Typically, energy represents about 30% of their operating cost. Now, to be clear, again, most cement people don't realize or think energy is controllable. And so this organization, it's a multi-site organization, but we dealt with one particular location. We actually started to train people. They realized actually no one were getting their utility bills. It was going to head office, and head office was splitting the bill by 5, and they were actually being overcharged when it was being averaged. Not appropriate, not acceptable. So ultimately, what we did is we built this whole, empowered the organization from the CEO down to developing teams at a site. And the site actually started to find all sorts of opportunities. Today, they've been operating over the last 15 years. They save over $10 million, if not more, a year by having this operating system running in their organization. Now listen, I'm explaining this because this is done in the past. These are 3 organizations that did nothing on energy before, and now they are. What's really going to be interesting is a lot of this was manually oriented and involved. Now in today's terms, we're working in AI, we're actually applying AI and generative AI, so effectively we do not have to do a lot of manual pull. We can actually do this work with generative AI. So it will allow us to scale this and do this work anywhere in the world. And so it will be more cost effective, but it will be a requirement that the customers will need going forward to manage energy, because if they don't, their business will not be sustainable. They may not have power, they may not be competitive, so they're going to have to think differently. So in summary, there's a couple ways. Most manufacturers think they have to buy equipment to solve the problem. You just have to look around this hall and see all the equipment. Equipment is important. That would be deemed as a project. But there's 2 categories that people don't realize that they do. One, you could do process, which means it's just changing how you do things in the organization. For example, when you get a utility bill, instead of just paying it, look at the utility bill and see if there's any issues or opportunities related to that bill. That doesn't cost money. That's just a knowledge base. Program, it's a small cost item, but a program we would define is an air leak program. Air compressors are one of the most energy intensive pigs in a manufacturing side. Studies show that air compressors leak 40% of the air that they use. 40%. The work that we have done with one of those organizations is that they put an air leak, and they did put an air leak program in every year that reduced their total company operating costs by 2% just by fixing air leaks and having a consistent thing. And then projects, obviously that's a high cost. You'll be looking at different options. But the summary is, it doesn't have to be expensive. And that's where we've been fooled. We've been fooled you have to buy equipment to fix the problem. You actually have to fix the people. You actually they have to understand how to work in the marketplace. So here's the 5-step process. First of all, you have to get data. And you have to get data that actually you understand and is valuable, and people in the company know how to use that data. There's a lot of data in manufacturing, but not many people actually understand it or use it specifically in relating to managing energy. And when I say that, it's energy usage, energy pricing, things of that nature. You have to train your people. You have to educate your people. So when we're in training people, we're covering 5 different steps. We're looking at data management, energy efficiency, supply side, organization integration. There's a variety of things that have to be looked at, and you look at through this in the different steps from process, programs, and projects. Summary is, if you take these 5 steps and they're built within the organization in everyone's role, you will save thousands and millions of dollars. And it's all manageable, and it's repeatable, and it should be repeatable year after year. This is not a one-time thing. This is not a one-year thing. This is a continual mindset that you have to have going forward. So I talked to you about AI. We are now using AI to do a lot of the work that we're talking about, or I mentioned before. It will be essential in the data collection to capture this data to make sure it's extremely accurate. And so we're now using that information to be able to share that with a variety of people from the organization, from the CEO to someone who's working in maintenance. And all the information they need will be a little different and presented in a different way, so they actually understand in their role what they do. So I'd like to thank you for your time, and I look forward if anyone has any questions. We're at E62. Love to share with you where there's opportunities where customers can save millions of dollars annually, best return on investment, by just following this operation way of thinking. Thank you for your time. All right. Is there time for questions?
Okay. Can you hear me? 1, 2, yeah. Good. Thanks. E60. E60. Okay. One minute. Yeah, perfect. Okay, hello everybody. This is Jakub Gara from Hatch. I will be presenting today innovation in asset management across power sector. Um, we are Hatch, perhaps a few words about Hatch itself. We are a global engineering consulting company. We are in 150 countries in terms of our project exposure. We've got 65 offices across the globe. We've been in the project delivery sector for over 6 decades, and we've got almost 12,000 employees across the world. Our closest office to here is Essen, Germany. for those interested. Few words about myself. Jakub Gara, I'm a regional lead for utility asset management in Power Business Unit, generally speaking. 15 years of experience, focused primarily on utility and power sector, renewables, nuclear power, thermal power, batteries these days increasingly, but generally speaking, energy sector, as you can see. Quick agenda for today. We will talk about the applications of asset management and what those mean to the utility sector. Couple of words about the technology stack. What are the solutions that utilities use these days? Probabilistic approaches, decision-making framework, so risk and value framework that help utilities make right decisions these days, and a couple of words about the data science and use case, which is very prominent now as it pertains to climate change. Okay, so very busy slide, but what really we're trying to say here is that there's a lot of use cases across asset management, whether this is for utilities or for large organizations that are asset intensive. Us at Hatch, we focus primarily on distribution and smart grid, hydropower and dams, everything power delivery, so large transmission substations and such, nuclear power and renewables. I'm not going to go through all these things here, but I will definitely focus on what we see as an innovation space or innovative technologies within these four buckets, which is strategic asset management, performance, investment planning, and digital. So I think in the strategic piece, what we see more and more is that utilities tend to develop more asset management plans for new assets, so for battery energy storage systems, for DER applications. In terms of performance management, we see quite a lot of probabilistic approaches, so using AI and machine learning to better understand how your assets will perform in the future. In terms of asset investment planning is something I mentioned earlier, which is risk. That, generally speaking, the decisions that utilities take these days to replace assets are based on either risk or value. And the last part, of course, is the digital piece, which is integration of those software solutions that help us facilitate the decision-making process, generally speaking. Few words about the technology stack. Here at Hannover Mass, it's quite evident that there's a lot of manufacturing clients that have the whole technology stack as it pertains to asset management, generally speaking. So anything investment planning, anything ERP related, this is something that is very common as it pertains to technology stack. Less common is asset performance management, which is the yellow bucket here, and in EAM, it's just something that as a legacy system, it's really a step forward from the CMMSs of the world, let's say. Generally speaking, what this is really trying to show is that there is a lot of components of the asset management system. Those components, different clients, different utilities, different manufacturing clients acquire a different time and a different, what do you want to call it, maturity of their asset management system. And what it means is that after after many years, that legacy system seems to have gaps, which we as a consultant are very happy to help with and build the fundamentals ground up for filling on those gaps. I'm going to start with probabilistic asset management. This is where we use quite a lot of AI and machine learning methodologies. Busy slide. We're not going to get too technical here, but what really we're trying to say is that a lot of clients, in this case utilities, have quite a lot of missing information. They have tens of thousands, hundreds of thousands, millions sometimes assets. You can imagine the largest utilities in North America and in Europe have north of 1 million poles or north of 500,000 transformers. These large populations have to be managed somehow. Typically, in order for us to predict the performance of the assets in the future, we have to understand how they acted in the past, how they performed in the past, what are the failure patterns. In order to establish those those characteristics and statistical methodologies, what we do is we use a number of we call it toolset and methodologies. Really, what it comes down to is statistics and machine learning, and some of the approaches that are quite old, but only now are able to really benefit the data scientists. Specifically, I'm talking about the Bayesian parameter updating, something that it's been around in mathematics, generally speaking, since mid 20th century, but only now we're able to actually take advantage of it thanks to huge computational power that every laptop really has these days. So on this slide, what you can see is a very common notion of Weibull distribution, which is the statistical. It's a probability distribution function for use typically in reliability engineering. Bayesian parameter modeling or parameter updating in this case helps us use some of the assets, existing information, to predict how those distribution would look like if we had the data that we unfortunately don't have for the assets in the past. In this case, what we're seeing here is actually a pad mount transformer, so your traditional distribution transformer that a lot of utilities have tens of thousands of. We were able to help utility defend in front of the regulator that their transformers fail actually much earlier than the filings from the past, which means that their capital requirements ended up being much higher. So as you can see, data science today is not just for performance management, generally speaking, but also for stakeholder management, in this case for the regulatory filing. Next bunch of slides will be about generally framework for decision making. So understanding how we can make certain decisions based on either risk or value. A notion here, you might see a familiar logo of a software solution called Copperleaf. They provide quite a good suite of asset investment planning solutions that we are helping utilities integrate. Generally speaking, we as Hatch are vendor agnostic, so we don't develop software, but we help either build fundamentals from the engineering perspective to integrate that software, or select the right solution for the right technology stack. In this case, what we've done for a large transmission utility is we build a quite comprehensive model that included 6 scenarios for probability distributions coming from different parts of the transmission system, and 56 scenarios for revenue impact. This is a utility that had quite a large generation portfolio, and the transmission system, of course, is the one that facilitates the sales of the power from that generation portfolio. Should any of the component of the transmission system fail, you might imagine that prevents that utility to generate revenue. So we were able to build the comprehensive statistical model here. And the really message here is that there's a lot of tools, there's a lot of data that utilities have, but fundamentally being able to digest the data, being able to understand what that data tells you is something that can really facilitate better decision making. Again, this is some technicalities here in terms of health index. Understanding condition of your assets is something that, again, helps you better fit the decision-making process in the future. You no longer have to necessarily replace the asset in case the asset is actually of good condition relative to its age. And inversely, very often we see quite massively degraded assets that we would expect that are in much better position or much better condition. However, they're in climate disaster prone areas, and therefore their condition is much more degraded. Again, we are able to use some of the typical statistics, but also quite heavy AI. I would call it AI engineering at this point, to predict better modeling of that condition degradation. So we are able to say, okay, at that age, we think this pole top transformer or this conductor will be of certain condition. And the last one is climate risk. So I think, needless to say, everybody's quite aware of their exposure to changing climate patterns, and the utilities supposedly are those that really try to understand how to make their grid more resilient. One of the utilities asked us to make them understand how much risks they carry on their assets, and not necessarily today, but in the next 10, 20, 30, 50 years. So we were able to see from their historical performance of their assets, historical outage events that were related to certain weather parameters, we were able to take some of the climate scenarios that are officially, some of the climate scenarios that are actually officially posted on in this case, Canadian government site. And based on those climate predictions, we were able to assess how much risk this utility is carrying moving forward based on those changing climate parameters. We didn't really use any software for this. This is just simple modeling and simple modeling with some of the AI that we build in house. Okay, and this would really be the key takeaways that I'm hoping to leave you folks with. Just generally speaking, what are the innovations and why the innovations and across asset management, not necessarily in the power sector? Well, risks. We actually are exposed to more and new risks. So we've got, the degradation of the assets is one of many, but increased climate resilience is something that the utilities look forward to increase, of course. But not a lot of attention is put at utilities at this point for cybersecurity risks, for instance, right? There might be quite a lot of that discussion on the IT side, but at the same time, making decisions in improvement of that cybersecurity resilience is something that utilities are increasingly looking into investing. Technologies, there are new technologies, but there is more importantly old technologies that now we're able to use more because there's just simply more computational power, and I know that I mentioned that Bayesian modeling being one of those applications. Data, there is more data. There is actually quite a lot of it, too much, one would say, and yet we are not taking advantage of that data, and simply because we are in the process of understanding what that data actually says. So we, as engineering consultants, are able to help utilities better digest and, I suppose, figure out what the data actually says and fundamentally help them make decisions better. And that's what we do in the utility sector specifically. And people, I suppose I would like to end up with this last piece here. Utilities do have millions of assets, but people are those that they pay increasingly more attention to, and I think this is a very good one from the perspective of investment. Demographically speaking, there is less and less people that are able to provide value to in the utility sector, and being able to help from the asset management perspective, we really like to say that people are the assets, and one of your most fundamental ones from the utility perspective. And that is it. Thank you, folks. Thank you so much. I would love to take some questions if there are any. If there are no questions, I'm happy to take any questions from our booth, booth C62, E62. Perfect. And I have a number of colleagues from Hatch that are able to help you folks with everything project delivery, ranging from energy through mining through infrastructure. So come and visit us. And we will also be back at 2:30. Thanks so much.
Hello. My name is Pascal Champagne. I'll be talking about how the NRC is playing a role in advancing hydrogen innovation in Canada. So a bit of an overview. First, we'll be talking about the NRC as a whole, for those of you who are not familiar with the National Research Council of Canada. Then we'll provide a few details on the Canadian hydrogen strategy, and then an overview of NRC's hydrogen capabilities across the country, and the integration of hydrogen programs across the National Research Council, and the potential for collaboration with Europe in moving the hydrogen economy forward. So the NRC is often known as Canada's best kept secret, which is not great because we really want to enhance the value that we bring in the innovation ecosystem. So we support Canada by fostering business innovation, aligning with government policy objective, and advancing scientific and technical knowledge. These efforts are integral to driving the country's innovation ecosystem and supporting sustainable growth. The NRC supports Canada's innovation ecosystem through several initiatives. First, we support business innovation, and this is very important. The NRC collaborates with Canadian businesses offering financial support and technical expertise through the Industrial Research Assistant Program, also known as IRAP. This helps our SMEs develop technologies, improve processes, and bring products to market. We also support government policy objectives. The NRC aligns its activities, its research activities, and its business activities, support activities with the federal priorities in areas like clean energy and health, and other, as well as a wide range of activities. It works with government departments to support economic growth, sustainability, and social well-being. In the area of clean energy, the NRC focuses on developing technologies that promote energy efficiency and sustainability, contributing to Canada's greener economy. We also advance knowledge and provide scientific advancement. So the NRC conducts research in a number of fields, from aerospace to biotechnology to clean energy transition, positioning Canada as a leader in innovation. It works to support industry standards and best practices. NRC also fosters partnerships with academia and global organizations to enhance knowledge and exchange and tackle complex problems. Overall, these efforts drive Canada's innovation ecosystem and support sustainable growth. A little bit more details. So about the NRC, we actually have two streams. One is our research performers on the left-hand side, and the other is our Industrial Research Assistance Program, or IRAP, which is focused on industry. Our research performers, as you can see, we have 12 research centers distributed across the country of Canada, more than 24 laboratories, again, across the country, as well as 126 major research and development facilities. So the NRC functions as a major research institution with extensive R&D facilities across Canada. It conducts cutting-edge research and development in various scientific and engineering fields, including things like aerospace, biotechnology, information technology, and material science. These facilities are equipped with state-of-the-art technology and staffed by leading scientists and engineers. The NRC research centers, the 12 research centers, focus on advancing scientific knowledge, developing new technologies, and addressing complex technical challenges. This research stream, enables NRC to contribute to national priorities, support industry needs, and foster innovation by developing solutions that can be applied in the real world scenarios. On our IRAP side, on the right-hand side, the NRC supports small and medium-sized enterprises, so SMEs, through our IRAP program. And the program is designed to stimulate innovation and growth in Canada. It provides SMEs with access to funding, expert advice, and connections to a network of industry partners and research institutions. The program helps businesses navigate the complexities of research and development from conceptualization to commercialization. NRC's IRAP advisors work closely with SMEs to support and understand their unique needs and challenges, providing tailored support to enhance their technological capabilities and competitiveness. This stream empowers SMEs to innovate, develop new products, and expand into new markets, driving our economic growth and job creation. So through these two streams, the NRC plays a crucial role in fostering innovation, supporting the development of new technologies. Its research activities address national challenges and contribute to Canada's global competitiveness, while IRAP ensures SMEs have resources and guidance to succeed in the dynamic business environment. So let's talk about our Canadian hydrogen strategy. So the Canadian Hydrogen Strategy is a comprehensive plan to establish Canada as a leader in the clean hydrogen economy, crucial for diversifying our country's energy mix and reducing our reliance on fossil fuels. By integrating hydrogen into sectors like transportation and industry and power generation, Canada can enhance energy security and support a low-carbon economy. The strategy promotes the development of necessary infrastructure and technology, positioning hydrogen as a versatile energy source that contributes to its transition. In addition, the environmental benefits, the strategy is expected to generate significant economic opportunities, including job creation and investment in new technologies. It aims to position Canada as a key player in the global hydrogen market, leveraging its natural resources and expertise in hydrogen production and technology. This initiative is a vital component of Canada's commitments to achieving a net zero emissions standard by 2050, as hydrogen can significantly lower carbon emissions when produced sustainably. By advancing our hydrogen economy, Canada strengthens its global influence and supports a sustainable energy future. So I find this slide interesting. It's a little bit busy though. So the reason Canada has a unique competitive and comparative advantage in hydrogen, it stems from its abundant natural resources, our existing infrastructure, and expertise in energy production. The country possesses vast reserves of hydroelectric power, natural gas, and renewable energy sources that are essential for producing clean hydrogen through methods like electrolysis and steam methane reforming with carbon capture and storage. This resource wealth provides Canada with the ability to produce hydrogen sustainably and at scale, positioning it as a key player in the global hydrogen economy. Additionally, Canada has a well-established energy sector with extensive infrastructure that can be adapted for hydrogen production and distribution, facilitating the transition to a hydrogen-based economy. Canada's strong research and development capabilities, supported by institutions like the National Research Council, enable innovation in hydrogen technologies. Another interesting slide for Canada. Canada's potential for hydrogen production is significant, and here you have it broken out in terms of provinces across Canada. And it's thanks to its vast natural resources and established energy infrastructure, which can be the dominant energy infrastructure can be different in different provinces. So we can take advantage of that, whatever the dominant energy structure and their distribution systems are in each of those provinces. So for example, the country has abundant electric power, hydroelectric power, and natural gas reserves, which provide a strong foundation for producing green hydrogen. Hydroelectric power, which you can see in British Columbia, Quebec, Labrador, Manitoba, enables the production of green hydrogen through electrolysis. And then our natural gas reserves, which are located in the middle of the country, Alberta, Saskatchewan as examples, can be used to produce blue hydrogen through steam methane reforming combined with carbon capture and storage technologies. These diverse production pathways allow Canada to generate hydrogen sustainably and at scale, aligning with global efforts to transition to low carbon energy sources. So Canada's existing energy infrastructure is also important, including pipelines and distribution networks. They can be leveraged to support hydrogen production and delivery. This infrastructure coupled with Canada's expertise in energy production and technology enhances the country's ability to expand its hydrogen capabilities efficiently. So since 2020, Canada has made significant strides in advancing its hydrogen economy through various initiatives and collaboration. The federal government has committed substantial investments to support research and development projects focused on hydrogen technologies, including fuel cells and carbon capture methods, and working on these in tandem. These efforts aim to accelerate the commercialization of hydrogen solutions and expand their application in sectors such as transportation and industry. Additionally, our provinces, several provinces, as you can see on this map, have embarked on their own hydrogen initiatives, contributing to the national momentum. For example, and I'm just highlighting two examples, Alberta, which is located second province from the left-hand side, has focused on leveraging its natural gas resources to produce blue hydrogen with investment in projects that integrate carbon capture and storage. On the West Coast, in British Columbia, which is really has abundant an amount of hydroelectric power. They've been active in promoting green hydrogen, supported by its abundant renewable energy sources, and has initiated projects to develop hydrogen fueling infrastructure for transportation. So partnerships between government, the different levels of government, industry, and research institutions have been crucial in advancing these regional initiatives, fostering collaborations and knowledge exchange. These developments reflect Canada's commitment to harnessing hydrogen potential as a key component of the clean energy transition, driving economic growth and achieving climate objectives. Now let's get back to NRC, my institution, for which I'm Director General of the Clean Energy Innovation Research Center, and let's talk about some of our hydrogen capabilities. So the NRC has substantial hydrogen capabilities distributed across different strategic locations, each of these focusing on distinct facets of hydrogen technology and research. These centers of excellence collaborate to push the boundaries of hydrogen technology and ensure that Canada remains at the forefront of global innovation in clean energy solutions. Through these specialized locations, NRC plays a pivotal role in driving Canada's hydrogen strategy forward, supporting the country's transition to a low-carbon economy. Now, out of my 5 sites across the country, I'm going to focus on 2, just to provide some highlights of the different types of research focus that we can have at different sites. My Vancouver site serves as a central hub for hydrogen and electrochemical cell research within Canada. It's equipped with state-of-the-art facilities that support a holistic approach to advancing hydrogen technologies. These facilities include specialized labs designed for electrochemical testing, characterization, where scientists and engineers conduct rigorous assessments of fuel cells and other electrochemical devices to improve their efficiency, durability, safety, and cost effectiveness. Vancouver's labs are equipped with hydrogen-safe operations, ensuring that research and development activities adhere to the highest safety standards in handling and utilizing hydrogen. Now, my newest facility, one of the NRC's newest facilities, which we're very proud, opened in 2023 and had a phase 2 and 3 expansion in 2024, in May 2024. And this lab is located in Mississauga, which is near Toronto. And it's a pivotal location for advancing hydrogen and electrification technologies, boasting cutting-edge facilities designed to scale up and validate materials crucial for these applications. Among its unique assets are an AI-driven electrolysis platform, which leverages AI and machine learning to optimize the efficiency and effectiveness of the electrolysis process, a key method for producing clean hydrogen. This platform enables researchers to refine and enhance electrolysis techniques, ensuring they meet the demands of a large-scale hydrogen production. Additionally, Mississauga houses a custom-built robotic 3D printing platform, which is instrumental in optimizing materials architecture for hydrogen application. This innovative technology allows for precise control over materials properties and structures, facilitating the development of advanced materials that improve the performance and durability of fuel cells and other hydrogen-related technologies. By integrating these sophisticated tools, the Mississauga facilities provide a robust framework for research and development and driving Canada forward and its capabilities for hydrogen production and electrification, and positioning it as a country leader. There are other facilities, but I would invite you to visit us at NRC to find out more about them. Now I want to focus on how we make sure that we're focusing on what these strategic areas are for Canada. And we do this through our programs. So different research centers have different programs. So for example, the programs within my research center, which focus on hydrogen, are my Materials for Clean Fuels program and my Advanced Clean Energy program. Materials for Clean Fuels the challenge program is dedicated to discovering and optimizing new materials that enhance hydrogen production, storage, and utilization, ensuring these processes are both efficient and sustainable. The Advanced Clean Energy program, or ACE, further supports these efforts by exploring innovative hydrogen applications and technologies that can be deployed across various sectors. And then when we move on the application side, we also collaborate with other research centers. Remember, there are 12 research centers. We're only one, such as the Aerospace Research Center and the Automotive and Surface Transportation Research Center, where they can apply the hydrogen through their low emission aviation program, or LEAP, which is accelerating the transition to net zero for Canada's aviation industry, or the Hydrogen Flight Research Platform, H2 Can Fly, which has just been launched recently, which focuses on investigating hydrogen and electric propulsion system. On the Automotive and Surface Transportation Research Center side, we have the Clean and Efficient Transportation Program, and where they're developing leading technologies in supply chains associated with low carbon mobility and sustainable transportation. So those partnerships become very important, and together these programs and research centers create a comprehensive framework for hydrogen innovation, positioning us as a leader in the global shift towards sustainable and clean energy solutions. Have a little bit of time to talk a little bit more about some of these programs because we do work in partnership with industry and academia, as well as other organizations. So our Materials for Clean Fuels program is a dynamic 7-year collaborative research initiative that's focused on pioneering the development of next generation materials essential for zero emission fuels and chemical feedstocks. So we look at CO2 conversion, large-scale hydrogen production, as well as AI accelerated materials discovery. In terms of large-scale hydrogen production, it's been one of the critical focus of the program, where the program was aimed to develop materials and technologies that enable efficient, cost-effective, and scalable hydrogen generation processes. In addition, the program harnesses the power of AI and machine learning to accelerate materials discovery, employing these approaches to identify and design new materials with enhanced properties and performance characteristics. So if we shift to our hydrogen pillar of the Materials for Clean Fuel program, so a little bit, it just shows you how we bring things from a low TRL level, so materials discovery, and bring it up to a higher TRL to be transferred to another program that addresses mid TRL to higher TRL applications. So the hydrogen pillar of the MCF program is strategically focused on advancing industrial hydrogen production by tackling transformative technologies that currently exhibit low TRL levels. This involves identifying and nurturing groundbreaking innovations that have the potential to revolutionize hydrogen production processes, making them more efficient, sustainable, and scalable for industrial applications. By concentrating on those early stage technologies and those winning technologies, the MCF program provides a platform for exploratory research and development, paving the way for significant breakthroughs in hydrogen technologies. Then if we move to our higher TRL level program, which is ACE, or Advanced Clean Energy, it doesn't just focus on hydrogen, but I will focus on hydrogen in my talk. It's a forward-thinking initiative designed to propel the development of clean renewable fuels and advanced energy storage materials. It's aligned with Government of Canada's ambitious targets to achieving net zero emissions by 2050. By prioritizing innovation in clean energy technologies, the ACE program seeks to address critical challenges in the energy sector, such as the intermittent nature of renewable energy sources and the need for efficient, scalable energy storage solutions. Now, focusing on the hydrogen pillar of our Advanced Clean Energy program, or ACE program, we see that the hydrogen pillar is a key component dedicated to advancing hydrogen as a cornerstone of clean energy solutions. The pillar focuses on developing and deploying cutting-edge technologies that facilitate the efficient production, storage, and utilization of hydrogen, thereby enhancing its role in the transition to a low-carbon economy. The program emphasizes innovative approaches to overcoming current limitations in hydrogen technologies, such as cost, scalability, and infrastructure challenges. And I would invite you to visit us if you want to find out more. Next, as I said, we often my research center is application agnostic, so we like to partner with other research centers or other organizations that have specific needs that they would like to adapt a certain energy material or energy source to a different application. So in working with the Automotive and Surface Transportation Research Program, we are able to achieve this. So the vision for the CEAT, or Clean Energy Efficient Transportation Program, is to support the development of clean and energy efficient transportation technologies while striving to a zero emissions future. The program works with industry, fleet operators, and helps accelerate the development and deployment of technologies related to aerodynamics, alternative fuel applications, batteries, electrical machines, fleet energy and efficiency, and hydrogen applications. Moreover, the vehicle-level capabilities allow for the integration of new systems for testing and demonstration purposes. So technology watch and life cycle analysis expertise are also leveraged to assess trends and overall environmental impacts and costs. And finally, our Aerospace Research Center has the H2 Can Fly platform, as well as their LEAP, so low emission aviation program, where the research center is really at the forefront of research into hydrogen combustion and fuel cells. It plays a crucial role in advancing hydrogen-powered aviation and does position Canada as a leader in clean tech aviation. Their research focuses on understanding the principles of hydrogen combustion, exploring its potential as a clean and efficient fuel for aircraft propulsion systems. So the integration of hydrogen fuel cells into aviation technology, aiming to replace traditional fossil fuels with hydrogen to significantly reduce greenhouse gas emissions and other pollutants. So, in conclusion, this is just an overview of the role that the NRC is playing in advancing hydrogen innovation in Canada, supporting the country's strategic goals, and fostering international collaborations to build a sustainable hydrogen economy. We look forward to continued collaborations with countries around the world as we continue the energy transition and work towards greater energy resiliency and security. I would invite you to come visit us in Hall 2. We have a huge booth as part of the Canada group. We also have a presence here in Hall 13 for hydrogen, but in terms of our presence across this site, or Hannover Messe, we do welcome you in Hall 2. Thank you. I'd be happy to take any questions if there are time.
Love to visit your booth. Folder is
tip 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 Check. So, hallo. 1, 2. 1, 2.
Okay. Hello. Good afternoon, everyone, and welcome. I'm Stuart Kramer, Chief Manufacturing Officer at Next Generation Manufacturing Canada. And today, we have a panel from Carbon Hound. Carbon Hound is an Ontario-based company that's helping companies to measure, reduce, verify, and market their carbon emissions. Incredibly timely and incredibly user-friendly. So they're here to tell you about their software and how they can help you become greener. With that, I'd like to introduce Lauren Chu, who will lead the panel.
Thank you. All right. Well, yeah, really excited to chat with the panel here about carbon management and reduction. Obviously, this is a big topic in manufacturing in general, and really even more important as the world looks to decarbonize even further and get ahead of kind of, well, do as much as we can towards reducing climate change and the impact that manufacturing has on that. So maybe we'll just start with a few introductions, and I'll let my panelists introduce themselves. So yeah, Sanders, if you want to start there.
I think I already got the introduction, but Sanders Legier, I'm the CEO and co-founder of Carbon Hound. So we work with over 160 businesses, partner with some of the largest businesses in Canada, and it's really about how we can democratize access to climate expertise and knowledge so that businesses of every size can make their impact.
Thank you, Sanders. Thanks to Carbon Hound for putting this panel, and I really appreciate it. And I think we are PTRC from Canada. I think you can see in last 2-3 days there is a strong emphasis to have a collaboration with Germany and Canada. I think it's the ideal time for all of us to be here. I think we are also working in carbon capture and storage. So we have a really good measurement, monitoring, and verification programs for storing CO2. I think we can talk more during your panel. I think we are currently stored 600,000 tons of CO2 in a deep saline formation in Canada. So we have a really good technology developments on that, and we are happy to share. Thank you, Lauren, for moderating this panel.
Awesome. So I think for just a high-level understanding of what carbon management even is as a definition, would love to just start there. And if Sanders, you wanted to give sort of that overview of what it is and why companies might do it, that would be really helpful.
Yeah, so basically, it's really simple. Anything that you spend money on effectively probably generates emissions. So what it's all about is trying to go through and look at your operational data, but with not the lens of finance, the lens of sustainability. And what we find is that sustainability and finance often go together. So what costs money also costs carbon. And so by taking a different lens on that data, you can start to uncover opportunities that you wouldn't otherwise find. And so why it's important, we've got about 90% of our customers are working with us because their customers are regulated. So there's about 70,000 businesses worldwide that are regulated against their climate emissions and therefore need to go into their supply chains to get an understanding of what that looks like. And as a result, what's happening is that carbon emission reporting is starting to become a lot like infosecurity, where it's just the cost of doing business. You know, if you want to work with large businesses, they need to have this data so that they can fulfill their responsibilities. And so for many of our clients, they look at it not only as, you know, a need to have, but also a growth opportunity so that they can get access to large RFPs that are increasingly applying more and more points towards green, sustainable aspects of their products and services that they're selling. And those markets are trillions of dollars, right? So there's a huge amount of momentum around how sustainability can be the third leg of the stool. You know, where previously it was just cost and quality, now sustainability is being added to that group. And so what we're finding is that businesses more and more are thinking about how they can integrate sustainability into their propositions to not only protect their existing revenue base, but also grow the opportunities that they see.
Yeah, and Rand, I would love to understand on the capture side, why is it so important to you, and why is it important to the businesses that you help with this?
I think Sanders made a really good point. You know, right now the environmental, social, and governance (ESG) is a pretty big deal right now. If you look at, the big problem right now we are facing in the industry is, if you want any investments for any major projects, even banks who wants to fund you or not, they want to see what kind of carbon solutions you have, how you are planning to reduce your intensity. So you are not going to get funding just like that, like previously. So you have to have a really good program. The organization like yours are going to help it. And what we are doing is we are taking our experience and knowledge, applying in the industrial setting. That's a very important. So the carbon capture and storage is a very important, because if you look at the emissions in all industries, steel, cement, like utilities, everywhere, you need to have a carbon capture and storage to really reduce. For us, it's really important because we are providing solutions to the industries, right? They're also looking for solutions. I think solutions can be done, like you need a software, you need a big capture mechanism, and also people wants to know how you are going to store the CO2 and safely, right? That's where people like us will come. So we have a really good experience in storing 600,000 tons of CO2. That's pretty significant. So we are helping the industry how to plan their projects. Even take an example, if you are building a big utility or power plant, so they will be looking, first question we will be asking is how many tons of CO2 you are going to produce. If it's a 2 million or 1 million, you need something to measure with your software, but also we need to make sure they're storing in the right location, right geological formations, right? So that's where we come into play. I think where we are going to make a big impact is about how do we can make this in an industrial setting, how we can help them. And also to help them to even finance their projects. They're not going to get an easy financing without a proper ESG strategy. That's what we are seeing more and more.
Yeah, that makes a lot of sense. I'm hearing, a lot of pressures could be coming from financing for opportunity. It could be coming from some sort of customer that's requesting this information. And I also understand, especially in this kind of global trade context, there's a lot of international and federal regulations that might impact a company or an industry to take action, to measure, and to report. Would love to understand a little bit more about some of those regulations and the regulatory pressures that are influencing and forcing these companies to report.
So I think they're all over the world, really, and they're only growing. So when we look at the global market, we're seeing that the regulated market is growing by about 4x over the next 3 to 4 years. So we're really just at the beginning of this trend towards increased, really, frankly, scrutiny around the climate impact of businesses and their supply chains. But obviously Europe is really leading the way. So you've got the carbon border adjustment mechanism, which is quite unique in the world, where they're trying to protect leakages of carbon. So for anyone importing steel, aluminum, hydrogen, et cetera, any high intensity carbon good is now being regulated effectively and tariffed in the EU. So they're doing that because as they put more and more regulations in place on their own heavy industry, they want to make sure that companies don't just start exporting all of their emissions to other geographies and then bringing it back in. So that's a really interesting one. And actually what you're seeing is that other countries are looking at adopting that. So in Canada, Mark Carney in the Liberal Party, he's looking at bringing that in if he gets elected as well. So I think what we're starting to see is, okay, how do we make sure that we're all playing by the same rules as it relates to the emissions that we're putting into our products and the regulations, because there's costs to meeting those requirements, and we need to make sure, in the EU we talk about the Draghi report, the competitiveness report, we need to be competitive, right? And part of that is making sure that we're normalizing the environmental impacts of these businesses so that we don't have people taking advantage of that in other jurisdictions. The other reporting standards like CSRD or in California, they also have SB 251. These are more like corporate reporting standards where if you're over a certain size, so in California, if you're over $1 billion in revenue and you're doing business in California, you have to go into every single supplier and go through your scope 3 as well. So it's creating what we call these ecosystems of pressure, where a Walmart or a Costco, they're being regulated, and so it's creating a domino effect on these supply chains. And same thing with Europe. There's, I think, 60,000 or so companies that are going to be regulated over the next few years in Europe. Same impact internationally as well. So those are the two major ones. And then the last category, I would say, is looking at greenwashing, right? So you've got more and more greenwashing regulations all around the world. And for businesses that want to sell into Europe, into the UK and Canada, the US, increasingly you need to be really aware of what kind of environmental claims you're making. And increasingly you have to have more data backing every single claim that you want to make. And so those are kind of the 3 different drivers that we're seeing for most of our clients. And then there's the obvious ones around, being critical to talent attraction and retention and culture at these organizations as well.
Yeah, and then I guess what I'm hearing from that is that the integrity and quality of the data that you're using to measure your emissions is really important for greenwashing, for regulatory reasons. And then I would love to understand on the capture side, like when it comes to integrity of what you do with those emissions after you try to reduce as much as possible and you've got CO2 that's left over, would love to understand from your perspective that high integrity and how important it is on the capture side and on the reduction side.
No, that's a great question. Shahnaz, you made a really good point about that, the price on pollution is not going to go away. It's going to be continue. It's very important. So our project where we are having a real-time monitoring of the CO2, right now the project in Saskatchewan, Canada, they captured 6 million tons of CO2. And you are reporting that. And our main job for our CO2 storage, we have a 3.4 kilometer deep well where we're injecting 300 to 600 tons depending on the day. So we have a real-time monitoring. The most important, just monitoring not for our purposes, it is to report to the regulators. So we have to make sure that we are looking at all the aspects of the regulations. No leak, soil sampling, water sampling, and we have a geophones, we are having a seismic monitoring, and we have a 32 technologies for monitoring. The reason is we want to make sure that the integrity is very important because if there is a carbon credits come into play, there is going to be a huge market. They are talking about carbon credits are going to be like a billions and billions of dollars of market in the future. If you're trading your carbon credits, you need to have a proper measurement, monitoring, and verification, right? So the integrity is very, very important. So that's what our expertise is. Make sure that the regulators are happy, and also the public consultation. We totally have to remember how we are going to justify to the public that whatever you're doing is right and it is safe and secure. So you need softwares, and most importantly, the measurement has to have a lot of integrity. And again, the regulations are different in every country. But in Canada, we have a really good regulation, a lot of experience. And at PTRC, we are involved with the ISO standards for carbon capture and storage. It's called CS275, and our director is the chairman for the standard developments. There is almost 26 countries involved, but Canada is leading that. So we have a lot of examples to set to follow the proper standards, because you don't have too many different standards, then you are not consistent, right? I think the consistency is very important when we are make sure that there is integrity in what we are doing.
Yeah, I think what companies feel is that there's a lot of barriers to getting started with this work, and there's so many different frameworks and there's so many different standards. And if I'm a small, medium-sized company, I don't have the resources to understand that. I don't have the time. So I would love to just talk about some of those barriers to entry when it comes to how long this is going to take, what does this cost, a lot of these practical first steps that companies can take once they understand that this is something that's a real risk and opportunity for their business. What are those common barriers, and how do you help companies kind of get through those?
I think I can start that. I think what we have done is, thanks to our Canadian government, there is some funding program we got. They asked us to develop a training program for industrial customers. So we started the training program. The most important thing for the aspect of any CCS project is risk assessment. So we are helping the companies to start with the risk assessment, and also we are helping them what are the process you have to go through, and also what is the regulations in your jurisdiction, how you are going to do it, and selecting the proper capture technology, proper measurement monitoring and verification, and most importantly, whether you have a right geological formation, or how long is the storage and transportation will take. So we have done some work in Vietnam, and we have done that pre-feasibility studies. So you have to start small. I always believe, start with the pilot first before you go on a big project. I think it's, starting small and understanding that. That's where the expertise like us will come, is we help you with that process, how to start and how you can develop, because every jurisdiction, every country is different, right? So we have to cater to that specific needs of the projects and the location. Like even Germany will be different than in Canada. Like if you look at the Asia is different, right? Even North America have their own way of doing things, right? But I'm not saying it's definitely not a cookie cutter. You can't just take it what we have done in Canada is perfect for a different jurisdictions. We have to really develop that. Again, with our experience, what we are doing is, we are telling them this is what we have done. You take this and you cater to your needs. That's very important. But it's very important to share the knowledge what we have done. So that's what we are trying to transfer our knowledge and expertise to the other parts of the world. I think the Germany-Canada collaboration is a perfect opportunity. So where we can jointly develop this kind of ideas and also how we can implement to those country specific.
Yeah, I think the collaboration is obviously critical, right? I think when we look at most of our customers, so when we started out, at least on them, we always say what you don't measure, you don't do, right? I mean, I think as a story as old as time when it comes to metrics in any sort of business. But when it comes to measuring, I think what it really comes down to is, okay, how do we get this data? So we found that 93% of our customers were getting stuck at that data collection stage when they're trying to start their first inventory to do their first carbon GHG accounting report. And as a result, that was really stopping people from doing anything. So we've spent a lot of time trying to figure out that particular problem. Because when you look at the research, it really just said, oh, it's capital and expertise that are the two barriers. But there's actually three. It's capital, obviously, it can't be too expensive. I think a lot of solutions that we were looking at when I was starting out, that are all designed for experts, have a lot of 3- and 4-letter acronyms and were $100,000 each. Okay, well, if we're saying that expertise is a problem, well, those 3- and 4-letter acronyms aren't going to help. And then you're saying price is a problem, well, $100,000 a piece of software isn't going to help that either. So we really tried to develop a solution that would be something that any company could use, and just to remove those barriers. Because what we noticed is that as soon as you get started, the momentum that you can create is huge. What we found is that there's a lot of people that want to do this work in your organization. You just don't know it yet. And when they get the opportunity to get involved and to actually, contribute to, some in sustainability or, a GHG inventory, they leap at the chance, and you build these relationships across your entire firm and momentum that you just wouldn't have otherwise. And so I think I always tell people, just literally just start. Just create a green team, start your first initiative, and I think you'll always be very surprised at how much people will want to jump on board.
Yeah, I think a lot of people look at carbon management as a cost center or as a kind of pain and something that they have to do or feel forced to do, but they don't feel excited to do. So I'd love to just hear, what's your advice to companies or industries who are looking at it through that lens, and what are the realities of the opportunities that are available and some of the risks that we already touched on regulatory-wise, but of not taking action and of not doing this kind of work?
I think David is walking here from here. I just want to highlight David. I think their company is doing really good work on carbon management. And I want to highlight because it's another Canadian company here. And they have been doing quite a bit of work on, like yesterday we were in a panel together. You mentioned that about how people are not looking at their own cost-effective savings, are looking at their energy usage. That's a very important part of that. I think, there are organizations, you need to look at your basic stuff, right? Before you're going and trying to fix everything, you know what I'm saying? First, you have to see what you have, how you can reduce your mechanisms right away from your own point of view, right? Then you are looking at, okay, then I have especially, what this kind of technology, what we are working on, it really works well for heavy emitters because they need the credits, they need the, opportunity, and also when the customers want to buy, for example, in the future, we want to buy this shoe, how are you going to say this shoe is made up of less carbon intensity, or even what you're wearing, or what I'm wearing, or even the suits, right? I think the measurements are very important. How are you going to justify that the products we are making are going to be carbon neutral or carbon friendly? There is so many different ways are going around, right? And the net zero or a carbon offset. I'm polluting here, maybe I can offset buying a credits, right? So we're going to have some challenges. But I think what I'm seeing is that everybody and everyone, general public or industry, they really care about reducing the carbon. It's not that nobody's saying that, don't care about it. I think there's a lot of interest in people that they really want to do something about it.
Yeah, I think fundamentally to that point, there's a lot of different reasons why you do carbon management. I think that number one is, how can we force our company to look at these KPIs in a different way? How do we improve our margins, our cost efficiency, our amount of energy that we're using, the amount of waste that we're producing, the amount of water that we're using? All of these things can also be viewed through the carbon management lens. And so it just becomes a different way to look at your business and think about different opportunities for you to save money. Like for example, a lot of our clients, they would say that just by looking at their bills every month, we've seen an observation effect of about a 12% decrease in costs, right? So even just being more aware of the problem by itself will create actions that you wouldn't have seen otherwise. Like there's one company who was saving 10% a year in energy savings because they just weren't turning off their machines at the end of the day, right? And so all of a sudden you bring that to your team and they're doing something about it. So there's a huge number of really low-hanging fruit as well as other kind of deep transformational work that you can do to push yourself towards a lower carbon operating model. And it really does open up new markets, right? So I think it's really about how do we build in a way that disentangles scale and climate impact, because I think that's the future of business. So there's a huge amount of opportunity there. And given the fact that we live in a world where it's extremely high expectation but low trust for businesses, we need to do that in a way that's transparent, because it's not just our customers that are going to care, it's also our employees, it's our investors, it's our creditors. It's almost every stakeholder who's looking at this more and more as a risk factor.
Yeah, it feels hard to start, but with technology, hopefully making that path a little bit easier and almost inevitable, right? So it's how do you get started, use the technology and tools that are available to you, use the funding, the training that can be available, and use this to your advantage as a business. And I think with especially a lot of people feeling really negatively and stressed about climate and like we're not taking enough action quickly, I really do just want to understand from both of your perspectives, you know, what keeps you excited about this? What keeps you working on this problem? And if there's anything that you're really looking forward to, like what kind of gives you hope when it comes to the work that you do and carbon management?
I think that's a great question. I think, one thing is, like I said in my previous answer, is people really care. Industries care, the governments care. They all care about this issue. It's not going to go away. I think the one thing I'm seeing a little bit gap here is there is a public awareness is missing. And also, if you look at that, I did my engineering, like I don't know when I graduated, it's been a while ago, but that time there's not enough emphasis on, we went to school, I'm an engineer by trade, we just go and take those classes, right? But I'm seeing most of the universities and even schools, they started introducing those renewables and the green stuff, and even there is a program specifically for sustainability. So these are the very important things I'm excited about, because I get invited to go to a class and university to give a lecture about what we are doing, and most importantly, not just about the technology, what we are doing. I'm talking about why it is important to think about how industry is thinking about people. Like we need more engineers, and we need more business people who have a techno-commercial thinking about carbon management. And when we develop those opportunities, that's what I get excited is, we put together a training program for a Southeast college, for a small college. We have a session, for a whole day session, for politicians, like elected officials who are taking the training, very high level, about carbon management, what we are doing in carbon capture and storage. So then they can, you are informing the elected officials, you are informing the students, you are informing the general public, like, the town hall meetings and stuff. Then when we are making a decision, when we are bringing those policies and whatever tax, whatever you call that, carbon neutrality, then people understand, right? Okay, I know what is happening. So we don't want to go and tell this is the technology, it's going to work. It's never going to happen like that. So I think that public awareness and the education piece is very important. That's what really excited, because you always want to share what you are learning. You know what I'm saying? That's what I'm really excited is, okay, we have done something, but how can we use that experience and knowledge to develop a comprehensive model to support the, this market moving forward? That's what I'm really excited about.
Yeah, Sanders, I'll let you answer the question, but I think the thing that really makes me excited about that is that there's lots of public information about how badly things are going, and there's not enough information about solutions, right? There's not enough information about the work that people are doing to take CO2 out of the atmosphere, to measure, to reduce, to do all of this. And I think that education goes both ways in that sense, right? Like we need to be made aware of the problem, but we also need to be made aware of solutions so that smart people and excited people work on those solutions collectively. But yeah, Sanders, what makes you excited and hopeful?
So many things, honestly. I think number one is obviously our customers. Like whenever we talk to our customers, they tell us these incredible stories about how they're trying to push the agenda forward in terms of saving their own costs. Like we had one guy who he had a large door, like a loading dock door, and he couldn't get, like his bills were insane for the heating during the winter. And he tried everything, he's looking at, could it be motion sensor, doesn't matter, like none of it was working. And so he finally, he finally set it up so that every time the door opened, the heating would turn off. So the theory was that the guy who was manning the door would get cold and then close the door on the delivery dock. And guess what? His cost savings went down by, his costs went down by like 50, 60% in terms of his heating bill over the winter, because I'll be damned, he put that door down pretty fast afterwards. And it's small moments like that of ingenuity that people create that I think is just so inspiring, that they're thinking about these problems and how it can impact their business materially. And we get to see that every single day. And not only that, I think the other thing I get really excited about is that you look at where we're at in terms of the maturity of these green technologies. The cheapest kilowatt of power is solar now, right? These solutions that we need to transition are in many sectors already here, and it's just the future isn't equally distributed yet. And so it's super exciting to start to see how companies are able to inject these technologies into their day-to-day workflows and really reduce their impact, while also at the same time also seeing this pipeline of technologies that are still yet to come that are going to help solve these problems in different ways and address things like transportation and sustainable flight. It's really, really exciting time, I think, to be in this industry, because there's so much innovation going on and so much money and so many brilliant minds working on this problem. And it's what a thrilling time in history to be part of this.
Yeah, thank you so much. I definitely hear that a individual rolling down a door doesn't feel like much, but if that happens across 10 companies today and then 20 companies tomorrow, and then it kind of grows that way, it's also this notion of green business or climate positive business being just good business in total, right? You're saving your company money, you are opening yourself up to more opportunities, you're kind of using sustainability in its most comprehensive sense, in that your business will continue to be successful as climate changes, as the world changes. So I think that's a very nice positive way of kind of wrapping up this immediate session, because I think we all need a little bit more climate positivity these days, and just awareness of solutions that exist. So really appreciate both of your time, and would love to just open it up if anybody else here wants to join the conversation and has any questions for either of our panelists. Cool. All right. Well, thanks so much for dropping in. Thanks for caring about carbon management and reduction. And enjoy the rest of the show.
Test, 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 test. Yeah, all good? Okay. Okay, awesome. Thank you so much. Okay, so I'm Brendan McDonald. I'm the CEO at Xterra, and Xterra is a startup, and we've developed and patented innovative new Stirling engine technology that allows us to convert heat sources into electricity. So, there we go. All right. So the problem we're solving here is that electricity demand is skyrocketing right now. Everybody's electrifying everything, and what we're seeing is grids can't keep up with demand right now. And they're looking specifically for clean, reliable, and affordable sources. So a lot of the renewables we turn to now struggle in the reliability aspect. And so what a lot of grids are doing is turning to fossil fuels like natural gas. At the same time, there's an incredible opportunity. When you look at energy production globally, 70%, 70% of the energy we produce globally is lost as waste heat. 70%. If we can convert even a tiny slice of this into electricity, that's a massive amount of energy. At the same time, this aligns very well with carbon reduction initiatives, because when you look at the pie chart here, in the difficult to eliminate emissions section, we have industries like steel, cement, load following electricity, all of which have enormous amounts of waste heat. So this aligns really well with converting their waste heat they already have into electricity, saving them money and reducing carbon emissions at the same time. The question, though, is what technology do they use to do this, right? So if you look around now, heat to power traditionally would be done with steam turbines. Steam turbines need to be massive to be efficient. So the steel mills that we've spoken to have said, we looked into steam, they cost a ton of money, they need to be huge, we don't have the space, we don't have the money. ORCs, organic Rankine cycles, is another technology that can convert heat to power. Same basic idea. They need to be really big to work well, and they need to be really big to make financial sense. So there's a whole bunch of applications where there's heat available, but they don't have the space and the money to use these massive 10 to 25 megawatt systems. So enter the Stirling engine. And if you might be familiar with Stirling engines, they're a 200-year-old technology. And so I'm a professor in mechanical engineering. And when we teach thermodynamics, you always teach Stirling cycles first. And you say, hey, listen, they're the best way to convert heat into power. They have the highest efficiency, and they're external, so they can use any heat source. But then the reality is you look around, and there are no Stirling engines anywhere. It doesn't make sense. We have all this waste heat. Here's the best technology for converting that heat into electricity, yet there aren't any. So we started on this project by looking into why their max efficiencies are so low, why they're using only fossil fuel sources. And basically we discovered that past engines will follow this solid line right here. And this is a pressure volume curve. It's showing the amount of work produced. So if you're using traditional Stirling engine technology, all the blue area here is the work that's lost. And this was a fundamental drawback to Stirling engine technology. We would actually argue that past Stirling engines should not be called Stirling engines because they're not following the Stirling cycle. And when you add all this up, they're losing 30% of efficiency right off the top. And so our first challenge was, can we make a Stirling engine that properly follows the Stirling cycle, which is the dash line here. So here's the data from our engine. And you can see, comparing the shape, we're able to much more closely follow the Stirling cycle. And that's why our Stirling engines are fundamentally different and why we can start to tap into these heat sources that nobody could previously utilize. So how do we do that? That's the big question. What we've done is created a cam groove profile here. With advanced modern machining, we can create a profile that controls the motion of our displacer. So by following this groove, we're controlling the motion of the displacer and following the proper Stirling cycle. The second piece, I should forward this. The second piece here is our regenerator design. Regenerators are key to Stirling engine technology. What the regenerator does is it stores the heat as the air moves between the hot side and the cold side. And because it stores all that energy, means you don't have to add it in every cycle continuously. And in the past, they would just take things like steel wool and stuff it in there, and think like that would be a great heat transfer medium, which is fine. But what we can do nowadays is use 3D printed metallic structures. And because we can 3D print the metals now, We can control the surface area precisely, and we can control the direction the air moves in. So we can make clever pathways to enhance the heat transfer. So those are our 2 patents. The regenerators is patent pending. The patents are already granted on the motion control system. So that's what allows our Stirling engines to achieve much higher efficiencies. This is our benchtop prototype here. So what we've essentially done now is we've made a unit, we've showed that it works, we have the data to support that we're following the Stirling cycle more closely, showing that we can do this very efficiently, and now we're looking at moving into the piloting phase or the field testing phase. And essentially what we want to do with our pilots is we install the Stirling engine right where the heat's produced. So our first partner is a steel mill, and we can literally mount the engines right on the side of the stack and produce electricity. The reason they love this is because it's hard to move heat around, but it's really easy to move electricity around. So if we can make electricity right where the heat is, they love that. And essentially, it's easy to install, but what the steel mills really want is no interruption to their process. So we can go down, they don't care. When they're in a shutdown, they set it up so we can install it, and literally nothing can disturb their system. This is our first partner here. This is Gerdau Steel, and this is us at their Cambridge facility. They're the largest producer of long steel in the Americas, and what we've done with them is they've actually agreed to fund our first pilot. So we're doing a small-scale pilot this fall. That's just 1 to 5 kilowatts, very small unit. Once they're satisfied that that unit is reliable, immediately they want us to install a larger scale one next year, so 2026, to align with their shutdown schedule. We're looking for fall of 2026 to do a full-scale production unit. So that's where we are right now. We're also looking at other partners. So this is the size of the unit right here. It's a CAD model because we're building it right now. And this is what it looks like. That's their stack right here. And we're going to install literally right on the side of the stack. As I mentioned, that's a small 1 to 5 kilowatt unit. What's kind of mind-blowing here is they gave us the exhaust data for that stack. That stack is at 800 degrees Celsius, and there's 5 megawatts of thermal energy. 5 megawatts of thermal energy in that one single stack from one single furnace at our steel mill partner. So if we take even a fraction of that energy, that's a huge amount of energy. If we could come in at 20% efficiency, that's a full megawatt. We've also talked to cement facilities. There's a lot of waste heat off their kilns. So this is Lafarge. We toured the Lafarge plant, and they're very keen to work with us as well. They're in the range of about 450 to 500 degrees Celsius. Right now, with our engine development, we could do anything above about 300 degrees Celsius. And that's a delta T, remember? So normally the cold side is room temperature. So anything 300 degrees Celsius above room temperature, we could handle right now. As we get more efficient, we drive those temperatures down, but we don't think we're ever going to go past about 200 degrees Celsius for our heat sources. Another big one for us is oil and gas. So there's a lot of compressor stations. Same idea. Off these compressor engines, which are natural gas fired, they're about 450 to 500 degrees Celsius as well. Biomass is a big one too. So this is actually a local wastewater treatment facility with enormous amounts of biomass. Our engines don't care what the heat source is. So we can use biomass, we can essentially burn anything and put our engine on top of it and harness that heat. So this is why we're at Hannover Messe, because we want to learn about our customers' needs and understand who has waste heat available. So essentially, we're looking for more pilot projects right now with different kinds of partners, and we want to align the need, the quality of the waste heat with the need. And so essentially, in looking at what kind of waste heat people have, the electricity situation, because the economic viability of our engine relies on how much people pay for electricity. And also looking at the situation with their emission reductions. Because our energy is clean, we can reduce carbon emissions as well. So we're actually profitable in our situation with the steel mill. The payback period there is 15 months with our technology. That's projected at current rates. And so even without carbon emission credits, we're still profitable. But it's a really good nice to have. And sometimes if electricity prices are low, it can help the economic viability of our engines. So we are in Hall 2 in the Canadian Pavilion in the startup section. So come check us out. Happy to talk to you. We have a little model, a 3D printed model of our engine. So yeah, happy to talk about that. And that's everything for me. So thanks for coming. Appreciate it.
contact number. They're probably.
Okay.
Thank you. No, so my...
This is working. It's good. All right, everyone, we're about to start. If you want to talk and listen about safety, please come and join us. Would you like to come and talk about safety with us? Right?
Yep.
Give me, I don't know, it's going to be 3 minutes. I'll introduce you. I like that. Welcome. Have a seat. We still have a few seats left. All right. As a good visitor and resident of Germany, I'm going to start now because it's time. So, guten Tag. Thank you, everyone, for joining us. My name is Stéphane Raymond. I'm the Regional Managing Director of Hatch in Europe. I'm looking after our operations here in the region. Welcome to our Hatch Working Together Safely event. For today's session, we are bringing together valued clients, partners, and colleagues to see how we can talk about safety and learn from each other to elevate our game in safety. Don't be shy, you can get closer at the back. There's still one or two seats left. During this session, there will be a keynote speaker. The presentation will be followed by a very interesting panel with different experts from the field. After the session, you're invited to visit us at the Hatch booth, just around the corner here, E62, where we'll try some ice wine from Germany and Canada, so another great experience. So you're all welcome again. So today our keynote speaker is Dr. Marcin Nazaruk. Dr. Nazaruk's background combines psychology of safety along with 2 decades of practical application across multiple industries at all levels of organizations, from the frontline safety managers to the C-suite level. The topic of his presentation is learning from normal work, how to proactively reduce the risks when nothing goes wrong. So if you think about it, how can you practice if everything is normal? So that's a pretty good subject and very interesting. And Dr. Nazaruk has studied this reality and will present us with his science-based perspective on how industries can get ahead of failure and identify accidents before they happen. And after that, the panel will continue. So please, Dr. Nazaruk, the stage is yours. Thank you, Marcin.
Thank you very much.
Welcome. Thank you.
Thank you. It's a pleasure. So let me just set here things. So welcome. It's a pleasure to be here with you today. My name is Marcin. It's like Martin with the C instead of T. And I've spent over 20 years in high-risk industries when I was bringing the science of psychology and safety into practice. My work attracted majority of the awards available in the energy sector. I was very privileged to multiple industry standards and guidance on human factors in investigations and learning. This is cutting off, right? All right, so we'll try with that one. Safety is evolving. Like any other discipline, engineering, medicine, it is changing as new research comes into play. And here you see an overview of 100 years of safety and some of the key ideas, from accident proneness in 1920s to behavioral science that originated at Harvard in 1930s, to human factors after the Second World War, normal accidents, safety culture into 2000s emerging from the nuclear industry, and then we see the emergence of HOP in 2010s, and the evolution is continuing. And so one of those areas is learning from normal work, which is human performance, human factors, safety to resilience engineering, operationalized for practical applications at scale in large organizations. And so here you see an operator operating a control panel. If I ask you, what do you see on the photo that increases the chances of this person making a mistake? What would you say? Well, yes, there are pipes in front that restrict visibility and restrict the movement. There you could also point to the control panel with the buttons red and green and very similar in shape, with buttons close together, and labeling with a small font that may be difficult to see from the distance, which is blocked by the pipes. Those things are easy to see. Now, if I ask you, what else there can be that increases the chances of pressing a wrong button, but is not visible on the photo? Yes? Right? So, for example, there may be a lot of noise. It's a little bit like here. But then we could say, what if this is middle of the night? This is 3 a.m. and typically this is a two-person's job, but the other person was called in for to another task. And what if the procedure is out of date and the technical drawing, PNID, is for slightly different layout of the equipment and doesn't represent what is in front of him? And what if the radio to the control room is broken and therefore he cannot call in and ask questions? And you see, all those different things increase the chances of making an error. Don't guarantee an error, but increase the likelihood. And importantly, all those things are there regardless of whether there is an incident or not. And so if there was an incident here and you did investigation, you probably would found some of those things that you see now. So every time people do the jobs, there is likelihood of a mistake. And that likelihood can be higher or lower depending on the conditions we call error traps. And so error trap is any condition that increases the likelihood of making a mistake. When there is an accident, it's easy to think that it happened because something or someone failed or malfunctioned. Similarly, when there is no accident, it's tempting to think, or it's easy to think, that all procedures were applied, all rules were followed, all controls were in place, and all barriers were effective. However, when we look into the work that did not result in an accident, we see exactly the same things that we see in accident investigation reports. People skipping steps in the procedures, working with incorrect tools, not having enough resources, and so on. And because I do that for a living, and I see that on a weekly basis, I'm happy to bet my money that I could take your accident investigation report, go to extract the findings, go to a different area or location where the same or similar job is happening, but there was no accident, and I would find the same or very similar problems that you found as causes contributing to the accident investigation. So typically, we think that if there is no failure, everything was fine. Now, here you see this very simple picture. Failure is very, very rare compared to the majority of work that is being done. And if this chart was statistically correct, the red dot would be so small that it would be invisible because of that ratio. But does it mean that all the work that did not result in failure was executed perfectly and flawlessly? Because if not, then that can give us a window into the opportunities in finding precursors of future event. And so now that takes us to the definition of normal work. Normal work is about how people adapt to changing conditions in order to complete their jobs. So for example, using a crane to lift a load. Every time an operator does it, there may be something different about the situation. For example, less time available than planned, additional people in the area, one person being off work, or the right type of lifting slings not available. So adapting to deal with these challenges is something that needs to be done. It is normal work. And so learning from normal work is about proactively identifying the things that make the work challenging, frustrating, variable, and difficult. And there is a growing recognition that we don't have to wait for an incident to find the causes of the potential accidents. Here you see 4 publications from different industries. From the right, maritime, aviation, the one I wrote for oil and gas, and then from the one from the US recently, highlighting and emphasizing that we can learn before accidents happen. And so the question now is how to do it. So I'm going to show you a number of examples of the tools that we can use and examples of integration with existing processes. Here you see a spectrum of different tools. From the left to the right, we see on the left, we see things which are short and easy, but also will take less time and give you less insight. As we progress to the right, they take more time, require preparation, arrangements, but also will give you more insights. And I'll give you a number of those examples. From the left, we've got simple conversation. We've got WTTT stands for walk through, talk through. I'll show you what it looks like. We've got integration with risk assessments or learning teams. But what all of those tools have in common is how we ask questions. So here, I'm going to show you 2 sets of questions. And imagine that I'm asking these questions to you about your task. And as I'm going through those questions, I want you to be very mindful of the emotion that these questions trigger in you, and whether these questions open you up and make you feel relaxed and willing to tell more, or whether they shut you down and make you feel defensive. Okay? So, I noticed you used a wrong tool. Did you follow the procedure? Why did you make this mistake? Now, with one word, give me an emotion that these questions triggered in you. Defensive, some people say attacked, some people say blamed, etc. So now let's compare it with the second set. Help me to understand your task. What makes this job difficult? How would you improve this process? Again, with one word, give me an emotion that these questions prompted in you. Some people say comfortable, listening, caring, supportive, involvement. So we see a big difference between your emotional reaction and to the questions on the left and the questions on the right. It matters how we frame the questions and what the questions focus on. Now, if we reflect on what's the difference behind? Why the questions on the left made you feel defensive and the questions on the right made you feel involved? Well, the questions on the left are so-called you questions. They focus on you as a person. I noticed you, did you, why did you? And they imply there is something wrong with you or about you. And therefore, these questions then trigger automatic, unconscious defensive mechanisms to this threat to a self-esteem, and that is experienced as defensiveness. The questions on the right focus on things external to the person. For example, this job, this task, this process. And so they do not imply there is something wrong about you, and that comes across as interest, showing care, and listening. And so now when we ask these questions, we can learn a lot about the reality of work. So a couple of years ago, Equinor, so Norwegian National Oil and Gas Company, conducted a survey with over 2,000 employees focused on discovering what makes following life-saving rules difficult. Life-saving rules are those that were associated with highest numbers of deaths in the oil and gas industries and are considered by the oil and gas and energy sector as critical to comply with. And so here we've got just an extract from the report focusing on working at height. And when workers were asked what makes working at height difficult, here are some examples of what they found. Because not areas are designed for climbing, even though you have to climb them. Or it's not always easy to know what can sustain a ton, because there is no information available about that. Or difficult to secure materials at height because the shape of those materials is not right, convenient, or shaped for securing. And so you see here are some examples of these aero traps that, that people experience. And so to help leaders with asking the right questions, we've also developed this deck of cards. So there is a 100 questions, 100 cards inside, and each card focuses on one type of aero trap. Here are some examples on the screen. Tell me about a time when you had to perform a specific task without being provided the necessary training. There are 12 categories there focusing on procedures, training, supervision, time, controls, tools, design, and many more. And so we've got many of those boxes, and after the presentation, there will be a panel, and you will be able to ask questions. And if you ask a question, you will get that box as a takeaway to take with you. So these are the conversations. So we were on the left-hand side of the spectrum. Now let's move more to the right. And this is where the walk-through, talk-through come into play. Walk-through, talk-through is a technique where we break the job into steps and then explore each step one by one to understand what makes each step difficult. And this is based on the foundational ideas of human reliability. And it's based on the recognition that different steps may have different potential consequence. There may be steps that can release energy that can kill. Other steps may not have that potential. And also that different steps are influenced by different aero traps, those conditions that increase the likelihood of aero trap or increase the likelihood of error or non-compliance. And so here you see a table with a couple different columns. And so in column one, we've got steps. So here we did a walkthrough, talk-through on a lathe, on the maintenance of a lathe machine. And so the steps are review the oil level, change the air filter, check the air pressure. Now, on the second column, we've got potential consequences. This is important because it helps us to prioritize which steps we should focus our improvements on. And then in the third column, we've got the aero traps. So now when we talk to the operator, if we focus on step 3, so the step 3 is to check if the air pressure is 85 psi, because too much pressure may damage the equipment. And when we talk to the operator about what makes execution of the step difficult, we've learned that the pressure units used on the gauge use megapascals, while the procedure for that step uses PSI, which means that the same physical pressure is now expressed with different numbers, which can lead to confusion or setting the wrong units. And so, based on that, we can discuss how this can be improved, and the easiest way would be to update the procedure to match the pressure units visible on the gauge. And so, next tool is called a learning team. A learning team is a group discussion. In this case, we talked to a small group of crane operators. Their job was to manage the simple lift. This is a 7-ton spool being lifted with a standard 10-ton crane, and the lift was up, side, and down. And when we asked them about what makes this job difficult, they told us that they are too close to the line of fire. They are too close to the spool. And this was because they had a cable type system to the crane. And so the control was forcing them where they could stand. That meant they could not see what's on the other side and how close they are to other obstacles. And that meant they needed a spotter. Now, they also couldn't see the spotter, so they needed to use verbal commands. Also, the remote had buttons like left, right, up, and down. So now, if you think about it, if we face each other and we both point to the same direction, my left is your right, that combined with the buttons, you tell me right, I press right, the load goes into wrong direction, and we've got a life-changing injury. So when we ask, what would you like to see being done about it, they say, just give us the remote control. And that's fun, that's fine. We've managed to install it in 6 weeks. And so what that did, it eliminated the need to be standing close to the load. It allowed the worker to move around, so they were away, they could see everything that they needed, and we also selected a different remote. Instead of left, right, we bought a design with the buttons west, east, north, south. This is not a silver bullet because it requires a frame of reference, so we also added big posters on the walls with the references. And so now, regardless of which direction they were facing, west was always in the same direction. And so here we were able to eliminate the risk of a life-changing injury. And so now there are a couple important lessons in this. Number one, if there was an accident during this lift, we would probably have found exactly the same things that we found now. Number two, so the things that would create an accident existed regardless of the outcome, just people were dealing with those things effectively most of the time. Number two, the things that reduced the risk were in managerial control, not in the work, not in the control of the worker here, because the worker is not in a position to replace a crane system. So this needed to go through the management team. Number three, the behavior, the unsafe behavior of being too close to the load was being forced by the layout and the setup of the work arrangement. And so we could be doing motivational speeches and behavioral interventions all day long, and that would not do much because they were forced to stand there because of the cable type system. And lastly, things that we found would not be considered hazards, and therefore would not feature in a risk assessment and would not be given thought by the safety team or by the management team when thinking about controlling the risks. So when we applied the learning teams in multiple locations over a period of 18 months in the US, we saw the reduction of injuries by 37%, even though this was a proactive effort. So this was not based on the investigation findings. This was based on proactively talking to people, and then we were able to address the error traps, and that reduced the risk, which then was reflected in the reduced number of injuries. And so here are the tools. Now I would like to show you some examples of how we can integrate this way of thinking into the existing processes. So one is behavioral observations. Many organizations have or had behavioral observations. And so let's start with challenging the underlying assumptions. Now, traditional way of thinking is that unsafe behavior is the cause of accidents. And so if we base our work on this presumption, then our focus will be on people and their behavior. And behavioral observations, behavioral safety can be a technique. However, if we change how we think about failure in complex organizations and consider the view that is more aligned with the scientific view, in that unsafe behavior is the symptom of other things which are difficult to see, then our focus is on error traps, and then we can use the learning from normal work as a framework to learn and to guide the discovery. Now, there are many different models exploring where do behaviors come from. Here you see a few points that come from a combination of hope, safety 2, and resilience engineering and failure in complex organizations. So here we would see behavior as a form of adaptation to the error traps and constraints, and those error traps are there because there are organizational factors that create them. So for example, the right tool is not available because there is something else in the organization, whether that's resourcing, whether that's planning, etc. When people make choices and decisions, they face dilemmas. Dilemma is a situation when you have 2 or more choices, and each choice has some undesired effect. And so there is that. Then there is a difference between how the work is imagined by leaders or by procedures and how it is actually executed or how it can be executed. And workers' understanding of the situation and the context that is often not visible for leaders. And what is important is that those things are often not visible to leaders. And therefore, it's difficult for leaders then to drive the conversation, expectations, or resource improvements if they don't know about those things. And so here are some examples. On the left-hand side, you see examples of behaviors taken from behavioral checklist from an international organization. We see failing to follow logout, tagout, not wearing PPE, distraction, or improper body posture. But when we apply learning from normal work and the questions, we can learn more about the context. So it's not enough to say fail to apply the logout, tagout. It turns out that the Lotto process takes almost an hour. The equipment can be disconnected just by pulling the plug. This is done in a remote location, and there is a maintenance backlog, which adds a pressure and to continue with the tasks. Or not wearing PPE, it turns out that the gloves exert a slight but constant pressure on the hand, leading to discomfort and over many hours to actual pain. Or distraction, that's easy to say, but it turns out that other process cannot continue without their input because we've got new employees there who don't fully know the process, and they keep asking questions and clarifications. Or the improper posture, that's easy to say, but the ergonomics training was 5 years ago, and there was no refresher, and this worker did not go through the training. So this is an example of integration with behavioral safety. Now I'd like to show you an example of integration with risk assessment. When we do risk assessment, we typically focus on hazards and then controls. Hazards typically are defined as something with the potential to cause harm, which typically takes us into the realm of energies or physical objects. So here it can be, you've got the list of the energies from the hazard as energy theory. And so you've got, if there is an exposed electrical cable, I touch it, I can get shocked. If there is acid, I touch it, I can get burned. However, things like out-of-date procedure, not the tool that is incorrect size, the equipment that is confusing, or not enough time available, well, those things are not the cause of harm in the same way as acid is. And so when we look into hazards and controls, we typically do not give attention to these conditions. But these conditions then lead to adaptations. So for example, if the right procedure is not available, some people may write their own or create their own checklist. Or if they've got a wrench and they want to unscrew a bolt, and the wrench is short, and they press with all their force, and that's not enough force, what they can do, they can adapt and put a pipe onto it, create an extension, which is called a cheetah bar, and that creates a lever, and now the same force allows them to unscrew the bolt. Now, when we see those behaviors, it's easy to judge those behaviors, and it's easy to say, oh, this is unsafe, this is incorrect, this is non-compliance, but it is a form of adaptation to a problem that existed with the existing tool. And so I'll show you how we can integrate error traps into the process of risk assessment. So if we take these two cans, let's explore how to differentiate between hazards and error traps. So these two cans, one is the lubricant, another one is cooking spray. Now, what's the hazard here? So hazard is something with the potential to cause harm. So what can cause harm? So I'll come back to it. So the harm is when I ingest the toxic material or the lubricant, right? So now what's the potential error? So error is a behavior that you can see. That's right. So now you're cooking, and by mistake you took the lubricant, or you want to lubricate and you take the cooking spray. That can go both ways. So that's the error. And now, what are the error traps? So what are the conditions that increase the likelihood of error? So positioning, yeah, so having them both next to your workstation, that's one, but there is more. That's right. Size, so they look very similar. So size, shape, color, positioning of the labels, of the logo, the black line, etc. And so the error traps are the conditions that increase the likelihood of error. Now, error doesn't automatically mean failure. You can pick the wrong one, realize it, and recover, and then correct yourself. So error doesn't equal an accident. And so here is a real example from a risk assessment. The task here is emptying chemical tank. And here we have job safety analysis, which means there were multiple steps for that activity. And then for each step, we would have this, hazards and controls. But then we added the two columns. One focused on error traps, and the second one on error traps improvements. And so here, the step was close the valve and disconnect the hose. And the original hazards were leak and burn, and the original controls were training and procedures. But when we talked to the operator about what makes it difficult, they said that they can disconnect the hose with the valve open, which would lead to a leak. And so why would that be? Well, because first of all, design allows for that. Secondly, it's not clear, there's no indication if the valve is open or closed. So the operator can think that the valve was closed, while in fact it was open, and then they can physically disconnect it. So with that, we were able to redesign the connection, make it physically impossible to disconnect the hose with the open valve, and then added also the indications, indications whether it's open or closed. And now, there is people lost lives because of those things. Here is a real situation that I described in the guidance I wrote for the Energy Institute. In one company, 2 workers needed to do a maintenance work on a valve. And so the risk assessment was done, the lockout, tagout, the isolation, all the proper process was followed. And then on the day, they approached a wrong valve because it looked the same. They opened the valve that was not isolated, and they were killed by the release of pressure. Which then, in the court, the judge said that the employer should have predicted the potential of confusing the valves and intervene and implement that into their management system. And the last example of integration is with accident investigations. So here, the incident was this worker was climbing this industrial skip to put in a trash bag inside. They slipped and broke their ankle. There was an investigation team put together, and they started with a typical 5 why and concluded that the design of industrial skip did not have the good access, and the worker wasn't paying attention. Now, when I asked this team to try again, but start with a different question, instead of asking why this incident happened, start with a question, what makes this task difficult? Then we learned that on this site, there were 10 skip models available, and 3 of them did not have the proper access. So then we explored, why so many? We went to the procurement team, and they told us, look, these are on lease. We just bring them as needed. They are different suppliers, and we don't have any specification on what's needed. So what we were able to do was to introduce the requirements, reduce the number of the skips, have just one model, and have a clear design requirements for what type of skips that we needed. However, there a very important lesson here. The corrective actions that stemmed from question, why did this incident happen, did not explore the full range of variability and other conditions that did not contribute to that particular accident. And many investigation techniques advise to exclude things that were not directly or were not contributory to that. So were other skips contributory? No. And if we just acted on that, we would not reduce the risk of a similar accident in the future, because there were other similar conditions in that work environment that had potential to create the same outcome, but were not contributory to the incident. And so changing the question based on the understanding that things that will cause your next accident exist today, and people deal with variability dynamically, and they need to adapt to those challenges. And all of that is existing and going on, and most of the time there is no accident. That enabled us to see more broadly into what creates risk and made us more effective with preventing a future accident. So thank you so much for listening, and I look forward to your questions. So we'll need the mic, but we have one. But for now, we can share.
It's the implementation of human factors and the Dirty Dozen. Yeah.
So Dirty Dozen is a particular framework from the discipline of human factors developed in the aviation industry. There are many frameworks. Dirty Dozen is not one. There are pros and cons to Dirty Dozen. Now, so where is the human factors? Human factors is deeply integrated into this without calling it out directly. How is it integrated? Well, in human factors, so the idea that the human error is a result of something else is coming from the research from the nuclear on human factors. The term that I used, error traps, is also used. There are other terms that you see in the discipline, such as error-producing conditions, performance-shaping factors, performance-influencing factors, which depends on the industry or the regulator. UK uses performance-shaping factors. In the US nuclear, we see more error-producing conditions. Human factors, however, is one field or one school of thought, yes, heavily based on research, but not the only one out there. You've got also human performance improvement that originated from combining the behavioral science and applied to organizations, and you've got the International Society for Performance Improvement. You've got the resilience engineering. You've got safety too, now mainly promoted by Eric Holnagel. They have some overlaps, but human factors and dirty dozen is not the only thing around. Thank you.
Thank you, Marcin. I would like to invite the panel to step up to the stage. So Gwen, Jim, and Andreas, if you wouldn't mind taking a seat. Thank you. Thanks, Marcin. I just so thank you very much. We're going to start exploring the question. My name is Bertie Brits. I'm the Global Director Health and Safety at Hatch. And we're going to jump straight into exploring this, this topic a bit further. But before we get there, I'm going to ask each of the panelists just to introduce themselves quickly. Gwen, maybe starting with yourself and then moving down. Thank you.
So, good afternoon. My name is Gwendolyn Groeneveld. I'm the HSE lead for LyondellBasell for the Global Projects Organization.
Thank you. Andreas?
Hi, thank you. My name is Andreas. I'm a mechanical engineer working in the energy industry since 25 years. I'm CTO of E.ON's Energy Infrastructure Solutions business, so everything what is non-regulated asset-based energy solutions business across Europe.
Andreas. Good afternoon, I'm Jim Sarvinas. I'm the Global Managing Director for Energy at Hatch. I'm also a mechanical engineer and 30 years now in Hatch and working on the engineering and delivery of projects around the world.
Thank you. So let's get into exploring the topic. So if each of the panel members can maybe spend a couple of minutes, minute or two, just tell us how this topic resonates and how this is applicable to your organizations.
Perhaps I give it a start. So first of all, Martin, thanks a lot for this very interesting presentation because you've covered a lot of topics that are really on top of our mind. So I will start a little bit from the other side, not from the just behavior topic, but for us at E.ON Energy Infrastructure Solutions, HSE is very much related to leadership. So we don't make something like leadership and HSE. No, HSE is a fundamental part of leadership because as a leader, the minimum standard you set is the maximum you get. This is the same like in sales. When you say you can buy this between 25 and 50 euro, you will always get 25. So always get the minimum. So it's a leadership topic. And secondly, it's about getting the employees in the Bradley curve and the complete recognition of HSE more from everything demanding in rules and concepts and processes, what we already have, of course, much more to an employee-driven safety culture. And this is what we're working on. And this we are, of course, everybody needs to contribute, and the leaders, of course, set the tone at this.
Thank you, Andreas. Gwen or Jim, anything to add?
So for LyondellBasell, and especially in the construction business that we are in, we get fewer and fewer and fewer of incidents, right? So we have to learn from when, like you said, Martin, when things go well, when things go right, or when we have just a little bit of a deviation from a rule or anything. So that is why we as LyondellBasell are implementing human organizational performance, and which also teaches us that blame fixes nothing and error is normal and likely. And that is that's something that we are very, very enthusiastic about.
Thank you, Gwen. Any other questions from the audience? Anybody else want to ask a question? No? All right. Marcin, I'm going to direct this question at you. So what role does worker insight play in learning from incidents? Or, sorry, learning from normal work?
Well, the insight is critical, the role, because the way people execute work may not be visible to the leaders for various reasons. And so then that creates that gap between how leaders believe the work is or should be done and how it is actually done. When things go wrong, then leaders act on their understanding and belief, and then it makes it easier to judge the behavior or to point a finger. So many things, many of those error traps that I was talking about are not directly observable. We cannot observe that the training that was given for the task was very theoretical and did not develop practical skills that we needed. It's not directly observable that the procedure is out of date and is for a different model of the equipment that we used to use on site. And it's not directly observable that I need 5 hours, but I have only 3 hours allocated by the planner. And so those conditions, they are visible and known to people who execute the work, but not those who manage or oversee or plan the work. And so without that insight, we really cannot improve, and therefore that insight is of critical importance.
Thank you, Marcin. So that engagement with the workforce and understanding what the challenges are, absolutely critical. Any of the other panel members want to add to that? Jim? Just hold the mic quite close.
Okay, yeah. No, I really feel that insight from workers, as you described it, is critical. One of the things that we do as an engineering company that delivers projects is to design and do the engineering for a facility. And, you know, I always say that safety goes hand in hand with quality. And in both topics, reaching the pinnacle of quality and safety requires getting insight from the operators and from the people who will construct that item which you're designing. So we try and spend a lot of time doing constructability reviews and operability reviews and gaining insight, because we know sitting in the office making calculations and drawings, we don't know everything. We have to talk to the people that are in the field using the equipment.
I can add here at this point, because I absolutely agree. Safety, quality, leadership, it's all the same, and it's based on the same bucket. And when we talk about construction on the one hand side, but also operations, we should be very clear that we don't get fooled by wrong numbers. So I'm very alerted when I go on a site and talk to people, and they are very proud about showing 5,000 hours, 400 days without an accident. This suggests a safe environment. But an absence of accidents is not showing that you have a safe environment where you're working on. So you need to talk to the people, you have to engage and really ask about what are the numbers about, and are they really true, or is it just let's say, a management figure where everybody feels happy, a happiness KPI. So we should be very careful and talk with people, talk and talk.
Thank you. Gwen, anything? Okay. Any more questions? Yeah, we've got a question.
Okay, this might be quite simple in a sense, but I was actually found your comment about setting up direction standards. That was a solution for the crane. It's very simple. It's something we should be doing in, I guess, most work plants. But I was wondering, is there other items like that? That's like low-hanging fruit. If I can tell people, go to the north wall, or I'm giving directions when I'm on a ladder and someone's below me facing me and I'm going to say I'm going to the right. That could confuse them versus going to the east, say. So are there a little list of simple things like that could actually improve safety all around? Communication.
Yes, there are. And the more they are based on the discovery from the workers, the more powerful they will be. Because that example, for example, with that spool, that was the case on one other site out of 100 sites. But we had, on other sites, we had other types of problems unique to those sites. So trying to generalize or come up with one checklist and then impose that would not be as effective, although it may be, or maybe at least give an illusion to that it's easier to manage. But for us, what we find is talking to people who do the work and discovering the variability. Variability is part of how the work is being done. And so dealing with variability in a way that is sufficiently flexible, but also combining that with thinking about controls and reduction of risk was powerful. And so, yes, there will be. Could I give you a list? I could. You could even take the cards and turn the questions into, each question could give you an answer, and then we can generate a list. We've got those lists. But imposing a list, I find, is not effective enough, because having whatever a list of 20, 40, 50 items does not account for the variability that is out there. And so it is more effective for us to ask questions, discover variability, and co-agree on what could be done. Yeah, because it's not always the same solution would fit, even if the problem is the same, because there is a variability in the conditions and resources and capabilities and capacities as well.
Thanks, Marcin.
Thank you.
And it comes back to the simple question of what makes completing this task difficult.
Yes.
Right, and understanding the specific circumstances for that specific worker in that specific situation.
Yes. We had a second question. Okay.
I'm coming from aviation, yeah, product support, and we implement the SMS, the safety management system, to implement organizational factors and human factors to reduce the number of errors. So maybe you heard about this one also. Safety management system, and also a lot of training to the people, to the mechanics, to reduce maintenance errors. In aviation, you can imagine it's very important to have aircraft flying, and if there's something going on, it's big media and things like this. So we call it SMS, and we do training for safety management system. Yeah, and implement also organization factors. Okay.
So thank you for that. Yes, safety management system is a common practice. Many organizations will have it. I also started training as a pilot, so I was enjoying the training on error reduction as a pilot as well. And you said one of the documents I showed you on the slides from ASSP, so the American Society of Safety Professionals, also now recognize the importance of integrating that with safety management system. So I think we'll see a growth of that integration, learning from the aviation industry, who is at the forefront in many cases.
Any other opinions from the panel? Or any other contributions?
Perhaps one thing to add, because I like the example very much, yeah, and what you described is also linking what you said. Safety and quality is quite close to each other, yeah, and I recall we had we're operating district heating grids, and we had an outage last year, and on the other side, on the district heating grid, was a big hospital. And when you then think about safety, it's not just about your own safety, it's also about your environment. So always be in safety one step ahead. Think about the quality, about the environment. I think this is something, a mind shift also, when you talk about safety as a culture and as an implementation, the complete design process.
Absolutely, and starts with proper planning. Gwen.
I just also wanted to, you were talking about when is work difficult. But we also asked the question, what are the things that you are doing that is really dumb, right? Why do you do not want to do this? Because, or what do you do is dangerous? or different, and especially with the skid. Right? This was different than other work. So that are also questions that we ask that can help you.
So a procedure or process designed in the boardroom doesn't necessarily translate well to the field. Again, important to get that insight from workers. Now, with that in mind, Marcin, I'm going to direct this at you again. So, with learning from work, how do you incorporate and account for many different nationalities, many different languages that we see nowadays, not just on construction sites, but in operations as well? How do we collect that insight in those situations?
Yeah, thank you. And so I'll give you some examples that what we did with different organizations. Recently, we had a project in Asia, so multiple languages. So first of all, how we tackled that is we trained the local trainers that were fluent in both languages. Then they started delivering that language, that training in their local language. We translated the materials. And then the supervisors now were equipped with those skills, and they could learn in the local language. That's the one. Number two is we recently developed so-called AI coach. So what is good about modern AI? It works in all languages. So the coach this is a technology that we use during the training. So the participants receive a scenario of unsafe situation, unsafe behavior, and then they have to ask questions. But before they start, they can choose the language that they are writing in. And the coach, the AI coach, gives the answer in two parts. Part one is respond as a worker. So we train it so to be sensitive to the type of question. If you ask close questions or a question that makes others defensive, the response will be on the defensive. And if you ask poor questions in the serious, they will say, oh, I'm not talking to you anymore. And then or if you ask good question, it will open up and it will tell you about the different conditions which are not directly visible or observable. And then it follows up with the feedback. So it will tell you the likely emotional response that your questions triggered, and what to improve, what was good, what could be improved, and so that is a series, and that works very well even in very local languages. So there is that. Now we also have technology of a live translation. So we have now the earphones that can speak live. So for example, when we go to sites where we don't speak the local language, I have two earphones. I give them one, and they hear me in the local language, and I got the translation in my language. So that's very helpful as well. And there is also a place for traditional translation, having materials in the translation. But here I wanted to share more recent innovation with the use of AI and what AI enables.
Thanks, Marcin. For the science fiction movie fans, that sounds very Star Trek. So, and you can actually buy those live translation ear sets on Amazon and some other online platforms that are available. Very, very interesting. Any other questions or any responses from the panel? Okay, so let's move on. So this being an interesting topic, new concept, if I have an existing health and safety management system, I don't necessarily want to redesign it. How do I incorporate and blend this approach into an existing system? Marcin.
Yeah. Majority of companies don't want to reinvent or throw out something that they have. So typically what we do, we explore together where would be a best way to start. Some companies start with leadership conversations, for example. So then we tweak that, and we tweak different components of that. So the process, the templates, the flow, the data collection. Other companies want to start with behavioral safety. Other companies want to start with risk assessment. And there will be some who want to start with just standalone program. But here what is good about it is this is the mindset supported by the skills and very flexible tools that can be injected into the existing processes in the organization. So you don't have to rewrite or reinvent the wheel, but rather tweak. Like with risk assessment I show you, we didn't throw it out. We just added 2 columns, and the two we were testing different options. Should it be one? Should it be just no new columns? The 2 columns were just most effective design out of different options that we've tested. And it's just tweaks, and we use the existing training with enhancement and existing templates with enhancement. And so that is very flexible to how this can be integrated with the SMS.
Thanks, Marcin. And I think we had a conversation just before the session as well. So it's great to hear that that can be incorporated and blended into a current system, because I think a trap that a lot of industries fall into is something goes wrong or doesn't go wrong, and the management team wants something new. We need something new because what we have is not working. Well, if you don't understand why what you currently have is not working, something new is not necessarily going to help you. It might fail for the same reasons. So something like this that you can incorporate into your existing approach is really, really great. Any other? Gwen?
I think that the first step of any implementation is training. Right? If we add another column, then people still do not know what they have to do with it. So we have to train the entire the workforce in either human and organizational performance or safety too or anything. But one thing that you can do that doesn't need any training at all is, as we have seen with Lined Up, that a lot of things go wrong when people do things for the first time. So we just added a little box which they have to fill out. Is this the first time? Have you ever done this task before? And if it's no, then they come back to us, they come back to their supervisor, and then they find a solution to execute the work in a safe manner.
Yeah, very simple solution. Okay, any other questions? All right, so in closing, Marcin, again from yourself, if there's one piece of practical advice that you can give to an organization looking into improving their health and safety performance, what would that be?
Give it a go. Don't wait for a fancy training. Don't do fancy stuff or whatever. Just give it a go, because there will be a learning curve for you as you try. And as you try, you will start exploring, seeing what's landing, what's not landing, what's working, what's not working, what's gelling, how people respond. And that's okay. There will be a learning curve, but give it a go. There is enough guidance available out there for a simple read, get some questions, and start exploring. Avoid why, explore what makes it difficult, and that will be the starting point of a new journey.
Thank you. Any closing thoughts from the panel members?
When something happens, do not start a question with why, or you, but we do not start it with why.
Yeah, so not a lot to add, but for me, it's, as I said before, it's a question of leadership and responsibility and setting the tone and showing and leading by behavior. It's not easy, and I must admit also sometimes for me also privately, when I see an unsafe situation, it's always to come out of the comfort zone, lead by behavior and intervene and help and support. Something is important for me.
Yeah, I really agree with Andreas there, and I guess my closing comment would be on the culture of safety, and as leaders, how do we instill that culture? I think one of the things is storytelling, and I learned a lesson early in my career, so I want to share a story. One of our leaders in Hatch was responsible for a project, and the project was almost finished. The construction started. We were working with another company in a joint venture. And anyway, as we were progressing, we learned information, and some of the engineers did some calculations, and we went and told our leader, listen, we underestimated the heat load in this building. If we don't change something about the ventilation system, it's going to be about 45 degrees Celsius in this building. So we have to make a change. it's not a good environment for the workers. Our joint venture partner looked at the problem and they said, you know, we don't see a problem here. We're not breaking any law. And our leader said, well, I don't care about the law. There's going to be human beings operating in this facility for the next 40 years, spend their whole life working and maintaining this equipment. We're not going to subject people to a 45 degrees Celsius working environment. And you know, the partner was concerned about the cost of the project and that would have an impact on our fees. And our leader said, I don't care. Take it out of our fee, you keep your fee, I'll sleep at night. So that's was a really powerful lesson for me as a young engineer, and I learned about, you know, the integrity required to make a safe environment. So I really am thankful for learning that.
Thanks, Jim. I think that the value of stories cannot be understated. Thank you very much. Our panelists are welcome to take a seat, and I'm going to hand over to Adele to close for us.
Thanks, Jim. Turn it off. Oh, okay, it's working now. Thanks. Oh, wow, I think it was an informative session, so thank you to the participants. Thank you for the members, and another round of applause for the panelists. I think it was, for me, it was like a journey. So Dr. Martin took us through learning from normal work. We I looked with interest to the human factors investigations. I think I'm going to go back and find those reports and learn from them a little bit. The error traps was great because the examples of the conditions and environment where we can make easy mistakes was also very interesting. So hidden misbehaviors are likely to exist in everything we do. Even if we don't have incidents, it doesn't mean we don't have areas of improvement. So that was great for me to appreciate that. And the normal work definition, I think this is an important one. So how people adapt to changing conditions and challenges as part of their jobs. I don't know if we think about that as a normal working conditions. So the way we have to have those conversations with our workers is important. Tell me how hard it is. What is how difficult that task? So that was also enlightening to me. So and then WTTT is great because it's you walk us through the 37% reduction on injuries due to a simple team learning over 18 months. I think that was a great example. We should try and see how we can do these team learning setups in our work environment. And then the behaviors is the symptoms of safety issues, and that error traps are the cause, not the behavior themselves. So error traps like procedures, training, equipment, design, time as well. Time was one of those examples. So you reminded us of the hazard behavior and error traps. That was great. So Andreas, the insight from workers, you mentioned site, safety, quality, leadership, operations KPIs. That was also important because you're right, the KPIs are reactive measures rather than focusing proactively on preventing or minimizing incidents. And Gwen mentioned the importance of influencing safety behaviors in construction environment, where sometimes you work with partners and others. And I think the combination we had with Andreas looking at operating facilities, coming from operating background, and you as well, Gwen, talking about the construction environment, that
that was also very helpful. Jim mentioned the safety in design and attach how we implement this, but we also, I linked the insight, workers' insight with the Rome application we have attached. We have an application that we use to collect insight from workers and how this insight help us to mitigate those risks, update our procedures, look for conditions, improve conditions. So that was also very, very insightful for me. So now we need to look into AI. How do we use AI in multi-language environment or other predictive measures? And that's something maybe in its own a topic that we need to address. But that's also an important adoption of technology in making the workplace safer and more predictable. So thank you so much for our panelists. Thanks for the audience. That was a very, very good discussion. We thank you for being here because that means you appreciate the importance of safety in what we do. So thank you so much. One more round of applause. This time for the audience. And now, if we can have you one by one coming to the stage, we hand you over a small token for your participation. Maybe start with you, Andreas. And Dr. Nazar. And Gwen. Maybe Jim come to the stage for a group photo.
Hello. Good afternoon, Hannover Messa. I am pleased to introduce our last speaker for the day, but not the least, Dr. Fenlo Zhu, Principal Research Scientist at Volta Energy. Dr. Zhu, over to you.
Thank you, Jerome. Yeah. Where's my- Why is the click? Oh, great. Okay. Okay, great. It's my pleasure to talk about our project of catalytic methane pyrolysis through carbon nanotubes here. So, in the opening ceremony and in these 2 days in Hannover Mess, we have heard a lot of things about AI. And yes, we are in the age of AI. And for AI, we need a lot of energy. To support the energy, we need a lot of good performance material. So, and we also have net zero emission target nowadays. And this gives us a large layer of restriction of energy and material. It's not that I can use any kind of energy. I can put petroleum oil or that black oil there. We need to rethink the obvious nowadays, how to make green energy and green material with high performance. So rethink the obvious actually is the motto of Volta Energy, the company of Volta Energy. Volta Energy was founded by Dr. Dennis Crosses. Since he was a child, he is so interested in cars. And as far back as in 2009, he had a vision of EV charger for electric car. At that time, not many people talk about electric cars, and he thought about that. And somehow in 2020 and in 2015, he co-founded Atom Tower company. And in 2020, Atom Power already started EV infrastructure charge. And he also founded Volta Insight. And in 2020, he also got a Volta Insight pilot project. And along this way, he also co-founded Zepco and Volta Spice. So that is a track of a successful story. If you are very interested, inspired by Dennis Crosses, you are very welcome to visit us at the booth B42 Hall 2. You can talk to him to see how he's successful along this commercialization way. And we talk about net zero emission, we talk about energy and new material. One good example is methane pyrolysis. So methane is a fossil fuel gas. But we can use methane in the green manner. For example, we can convert methane into blue hydrogen and solid carbon. In this process, there is no carbon emission, so it is clean. And hydrogen is a very clean gas, right? You probably have heard that. That is cleanest energy. There is no water carbon emission. One thing I want to mention that nowadays, a lot of people also talk about making hydrogen gas from water electrolysis. But compared to methane gas, 1 gram of methane can give you 0.25 gram of hydrogen gas. And water, 1 gram of water can give you 0.11 gram of hydrogen gas. So in this case, in this sense, methane actually is better to give you hydrogen and solid carbon. So we inspired by this one, we tried our experiment. We designed and synthesized catalysts at Volta Energy. Here we call it catalyst CF8. We did this methane pyrolysis in the tube furnace at controlled temperature, controlled methane flow gas. And if you compare to these two pictures, before pyrolysis and after pyrolysis, obviously you see something happened, right? After pyrolysis, it is become shining black and it become bulky. Something has happened. We have obtained carbon there. So we tried further at different temperatures. We tried from 400 to 900. So these activities, the net mass gain, the solid carbon you obtained, increased with the temperature increase from 400 to 900. But one thing you should pay attention to that, for literature research and pyrolysis usually happen at high temperature. For example, 1000 Celsius, 1012, 200 Celsius, 1200 Celsius. But ours, we can do it at 500 Celsius with good net mass gain. Another thing is that for our setup, we do not need a lot of catalyst. A lot of catalyst actually is not good. That is an advantage. So what do we get? Do we only get carbon nanotubes? So we did a SEM analysis. You see here, clearly, yes, we got carbon nanotubes. They are beautiful carbon nanotubes. So carbon nanotubes has superior properties. For example, it has such a strong tensile strength, and it has such good electrical conductivity. When it is so pure, when it is very pure, it is electrical conductivity can compare to copper wire. So that is very good. It is also has very good thermal conductivity, which means it will not accumulate heat. The heat on the surface of carbon nanotubes will dissipate quickly. So your phone, if made from CNT carbon nanotubes, it will not get hot one time after you use it, right? That is an advantage. Another thing is chemically, it is very stable, and it has a big surface area, and it is hydrophobic. So all of these contribute to what CNT can do and its application. So silicon has been foundation of computing for decades. So we have mobile phones very small, and we have computers become lighter and lighter. That's due to the FET, silicon played a big role there. But silicon itself now approached its physical limit in terms of the size. It cannot go further smaller, but carbon nanotubes can go to nanometer size. It can go to very small. So carbon nanotubes will power next generation of AI, and it has great application in AI. We said that AI, we need great energy. CNT will play a role there as a new material to support this energy. Another thing is that carbon nanotubes can find a big application in battery. Nowadays, we want to electrify everything to make our atmosphere cleaner, to make there is no carbon emission. So we need a lot of batteries, and CNTs, because of its properties, it can find application in battery. For example, enhance electrode conductivity, enhance its structural stability, and improve lithium-ion diffusion efficiencies, and increase specific surface area. And this plot here, this plot is real what happened in Canada. It's not predicted. And it actually is what happened in Canada. And it is a big application in battery. That is just two examples of CNT carbon nanotubes. So like everything else, so its properties, its performance is based on the structure. So it's the same for carbon nanotubes. Carbon nanotubes performance is applications based on the structure. Carbon nanotubes, usually we said they are single watt carbon nanotubes, multiple watt carbon nanotubes. Carbon nanotubes, we can think of that is a sheet of graphene sheet. It is rolled up, forming a cylindrical tube. So if that only one layer, we call it single wall carbon nanotubes. If the many sheets form these concentric tubes, and we call it multiple walled CNTs, right? And some CNTs has these chiral properties because how it is rolled up, and some things is chiral and some carbon nanotubes are non-chiral. So we said that armature, ziegfeld, they are non-chiral, and if this roll-up index, AM, they are different, and it will form the chiral. And this chironity affects its electrical conductivity. Another thing is aspect ratio of carbon nanotubes. Basically, the ratio of the length and to the diameter. So this also affects its applications and its performance. So from the catalyst CFA I mentioned, so what kind of carbon nanotubes we obtained from that catalyst? Let's have a look. This is TEM images of carbon nanotubes. We can see these curving nanotubes is curving, and we can see clearly is lattice fringe. We can see the diameter of this one. This was did at 500 C, and you can length between 0.7 micrometer to 9.4 micrometer. That is good length because you think the diameter is just nanometers, right? Aspect ratio is between 43 and 213. And we found out is rolled up NM is close to this one. So it shows it is chiral. And this is carbon nanotubes made by the catalyst CFA at 900. It is still curving, but you can see they are different. From the 900, you can see clearly is a cavity, right? Is hollow in here. And the length and the diameters are also different. So that is different from the different temperature. The different temperature has effect on the carbon nanotubes. And from thing here, I just want to show you this nice picture of TM images. And you can see this lattice fringe of this. Based on this lattice fringe, we can clearly see this D-spacing. At 500, this D-spacing 0.38 nanometer. At 900 is 0.35 nanometers. So it seems that this temperature also affects carbon nanotubes D-spacing, the lattice fringe of this. So inspired by this work, we went further, we developed more catalysts. We called CFB, CFC, CFD, CFE, and we tried at different temperatures. Here, I just want to show two temperatures. One is 500 to 900 to compare with each other. And CFD and CFE, unfortunately, we found they are not active at 500, but at 900, they are active. And CFE with relatively less carbon nanotubes we obtained, we only got the 126% of net mass gain. But for example, with the CFB at 900, we got about 900%. That is 9 times more carbon nanotubes we obtained. We use GC and TCD and GCFD to monitor this reaction because we need to confirm this reaction happens and carbon nanotubes we obtained, right? So TCD will detect hydrogen and methane gas. And this is GCFID. GCFID will detect methane gas and the other hydrocarbons. From this reaction, theoretically, methane pyrolysis only needed to hydrogen and solid carbon. But we also see something else like ethane, ethylene, acetylene, propylene, and propadiene, butene in this GCFD. So we call this a byproduct. So this is understandable. At this high temperature, 500, 900, something else also happened. But you see from FID, these things are very, very small. The amount of these things is very, very small, right? They are just trace of amount. So as most of research and scientists, as a bad habit. When they are doing something, when they saw something, they always want to know, okay, what is going on, really is going on. So I had the same bad habit. So I was thinking, what is going on in this reaction? So based on what we have seen, based on GCFID analysis and GCTCD analysis, we proposed this mechanism. So when methane come into the catalyst and interact with the catalyst, methane gas somehow split it into CH3 and hydrogen. CH3 further split it in CH2 and hydrogen, and further going on like this. And at some point, this carbon interact with CH, this group, and forms carbon nanotubes and hydrogen. Here, I just want to say one thing, why I think this is a road for the carbon nanotubes formation. It's not carbon react with carbon, because carbon deposition actually is a main source for catalyst deactivation. But we have seen that for these carbon nanotubes, we have very thin, very long carbon nanotubes grown on this catalyst. So which means the catalyst didn't deactivate quickly, right? So there must be something protected catalyst from deactivation quickly. So that's why I believe it is in this road. And further going on, hydrogen react with hydrogen, form hydrogen atom, react with the hydrogen atom, form hydrogen gas. CH3 works with CH3 form methane and some ethane, and further going on here. One thing interesting I noticed is that at 500 C, more methane is produced than ethylene, but at 900, ethylene is more than ethane. That is the temperature influence on this reaction, on these activities. So we said that we can compare its catalyst activity based on the net mass gain. And here we also compared its selectivity and lifespan. How do we calculate lifespan of the catalyst? We just use the ratio of hydrogen to methane. Because you can imagine, if no hydrogen produced, then you know catalyst is dead, right? So we know this, we use this ratio, hydrogen to methane, to calculate its lifespan. So we compared with 500 Celsius and 900 Celsius. You can see clearly with this catalyst, at 500 C, selectivity is very high. So on the GCFID, you see a little bit amount of ethane ethylene. So selectivity is very high. And the ratio of hydrogen to methane gas at 500 does not drop quickly. And for the catalyst CFA, CFB, and actually within the 2 hours, this ratio even increased a little bit, which means at 500 Celsius, these catalysts have good lifespan. For CFC, it dropped, but not dropped too much. But at 900, selectivity obviously is less compared to 500 C. One thing I want to mention that, if you look at the CFD catalyst here, in the first half an hour, this ratio, hydrogen to methane, is so high. But after the first half an hour, it dropped quickly at this. And for CFE at 900, so it didn't drop that quickly, but at the very beginning, so the ratio is not high. So catalyst activities, catalysts also influence carbon nanotubes produced. So with these different catalysts, what kind of carbon nanotubes we produced? What different carbon nanotubes we produced? Okay, let's have a look. So this is TM image of carbon nanotubes produced by CFC and CFB at 900. So you see they are still curving carbon nanotubes. You can see the diameter, and you can see also lattice fringe here. So length is between 0.7 to 4.8 micrometer, and the diameter is about 16 to 64 nanometer. Aspect ratio actually is good, to 29 to 103. And this is for CFB. And this is CFA, CFC, carbon nanotubes produced by CFC. They are also curving, but length is longer. Longest is 12.4 micrometer. And the diameter is also bigger. Biggest one, 220 nanometers. So it is in a wide range of diameter. And the aspect ratio actually is also in a wide range. So this sees the difference of catalyst for these carbon nanotubes, influence these carbon nanotubes formation. So here, this is TM images of carbon nanotubes produced by CFE at 900. We have seen some curving nanotubes for the previous catalyst. But see here, they are straight carbon nanotubes. This is made by catalyst CFE at 900. So we calculated the D spacing is 0.34 nanometer. That is very close to that literature report. And here we see the length is also pretty good, 10.6 micrometer with diameter about 41 to 83. And the diameter is not in the wide range, so usually, relatively, it is more uniform. It has good uniformity of here. Aspect ratio is also high. 290 is good with this one. So, and this one, this carbon nanomaterial catalyzed by CFD. So if you still remember, I said that for this CFD, it is very special. In the first half an hour, the peak ratio of hydrogen to methane was so high that it dropped quickly. And these carbon nanotubes produced by CFD, it is not tubes, but it is particles. We call it CNT particles. Why? Because you can see clearly from here, they are carbon nanotubes, right? Maybe in first half an hour, there are so much carbon nanotubes was produced, and there is no room to get longer, so they are all just rolled up and form these particles and balls. So that is very interesting. So the different catalysts, the different temperature make a different carbon nanotubes. Thermal stability is also very important for carbon nanotubes. We did the TGA analysis to assess its stability. And this is TGA plot for this CFA. So it is pretty clean, only one plot, and shows if from this derivative TGA, you can see a little bit peaks. I think that is due to the different diameter of these carbon nanotubes. The different thickness have a different small peaks here. And this is a TGA plot for carbon nanotubes made by CFE. CFE carbon nanotubes are straight carbon nanotubes, has relatively bad, good uniformity. So see from here, the peak is very clean. So it's a derivative only one side peak. So in the good agreement with what we have seen from TEA images, right? TM images about carbon nanotubes. So here is summarized of these carbon nanotubes specs here. We compared with carbon nanotubes made by CFD, CFA, CFE, CFC at 500C and 900C. At 500C, with catalyst CFC, we produced carbon nanotubes up to 12.4 micrometer and largest aspect ratio of 117. And it has good thermal stability up to 554.5 and 640. And with the CFB, we produced carbon nanotubes up to 4.8 micrometer with a largest aspect ratio of 103 micro ratio. And average aspect ratio is 64. D spacing is about 0.36. And it is thermal stable, for example, to 565 and 649. CFA make carbon nanotubes up to 9.4 micrometer with largest aspect ratio on the 213. and thermal stability at 554 and 662. At 900, they make different carbon nanotubes with different specifications. For example, with CFE, so we make carbon nanotubes up to 10.6 micrometer, and largest aspect ratio 219. Average aspect ratio 127. That is a very good number of that. And it's very thermally very stable, up to 637 and to 712. And you also need to remember this analysis was done at a very, very small scale. So with a big scale, so I think it will be stable maybe at an even higher temperature, right? With CF8, so we make a catalyst, carbon nanotubes up to 8 micrometer, and very thermal, has a very good thermal stability. And CFD, we said that we make carbon nanoparticles, not carbon nanotubes. So these are carbon nanomaterials we made with different catalysts at different temperatures. So in conclusion, we have made carbon nanotubes with different specifications, different parameters with different catalysts at different temperature. In other words, we can tailor carbon nanotubes up to your requirement, up to what the specifications you want. We can tailor this with different catalysts and a different process. So a lot of things I want to mention that with our technology, water energy technologies, we can make carbon nanotubes at 500 C. That is relatively very good temperature, very low temperature. And for your industry, you do not need such a high demand for your material. And will save you energy, save your cost. And at 500 C, we also get a very good amount of carbon nanotubes. So this is our team to make everything happen here. So this is our lab. So it was built from the scratch in the early of 2023. So far, 4 research and development activities going on in this lab. And this here is Royu and Anjali, our first 2 intern students. They did a very good job. They was the first one, right? They did a very basic job and made a foundation for us. And here in this picture, so our nice team with intelligent people like Gersran, Takis, and George. And this boy with green t-shirt, his name is Frankie. He is the second batch of intern students in our team. And this lady in red shirt is Professor Kessler. She works at university, and we collaborated with each other on a different project. This is our whole team here, water, energy, water spice. Not whole, but there are more in USA. So that is the end of my presentation. Thank you very much for your attention. If you have any questions, I'm glad to answer that. Thank you.